Hello everyone. Am I audible?
Yes, ma'am.
So let me start. I was waiting for some announcements, but probably let's start, which is already because we are already it's 2:10. So let me start. So is there any new so that I can introduce the details? Okay. Anyway, let me start introducing the things. So, hi, I am Dr. Tanima Datta. I am Associate Professor in the Department of Computer Science and Engineering, IIT BHU Varanasi. My contact details are already in the homepage. I hope you can see the slides, right? So,
Yes, ma'am.
Okay, good. So, as my area of research is basically artificial intelligence, computer vision, machine learning, deep learning. These are the wide areas I have. So in that domain, I have worked in some of the topics. So again, image and video captioning is one of the topics that I already worked with my students. So in that domain, today I will going to discuss some of the major things that has happened and where you people who are listening can actually do your research in the future. So what is video captioning or summarization? Like we see summarization of some of the videos, some of the images in the news, in the articles, right? So what are that? So let's say we take an example here. So this example is taken from one of my paper itself. So here we can see there is a musical performance is going on. GT means ground truth. Object means what are the objects present, because because objects are always considered as the front end things, right? That are important. And sequence to SEQ to SEQ is the sequence to sequence. So sequence to sequence is the most oldest captioning model that we normally taken as a reference. And VSB cap is the one which is generated by us in one of our paper. So, okay, now we can see that the GT says that before we come to I just want to say what is captioning. What is the word captioning? Image and video, we know what is mean by image and video. Image means image, videos means reels and videos. Now, what does the word captioning means? So, captioning means like if there is an image or a video, like say here there is a video. So, how we can just in one or two lines, how we can summarize that? So here GT means the ground truth that are already present in the benchmark data sets. So what for the first row, the performance is showing like a man is playing a violin on a stage. Or another ground truth. There are multiple ground truths, not one ground truth. So that the machine can learn from the ground truths in the training time. The man played the violin while the lady sang. These are the few. The only two examples are showing here, but I am damn sure there are in the benchmark there will be 10 or 15 ground truth for one video. So what are the objects here? Man, violin, woman, verbs. What are the playing and singing? These are the verbs. So in the very old models, what are the foundational models? They used to like a man is playing violin. They have not considered the latter part of the video. What we have generated is a man is playing a violin and a woman is singing on the stage. So that entire context of the entire video should be captured and finally the caption should be made. So it is more like, as I'll not say 100%, but it's more like human-like captions. Similarly, the second example is also like, what are the ground truth we have? Two boys are talking on a phone. A young man is sitting in a chair talking on a phone. So objects are phone, chair, man. Verbs are talking and sitting. The foundational model says a man is talking on a phone. So as a foundational model said, we take mostly the initial part of the videos. So what we have developed, a boy is sitting on a chair and talking on a phone. So that was what both the chair as well as the phone, all the objects it is tried to capture and basically project in the caption. So. So first row is the extracted frames. Then we have the objects and verbs, and with the GTs, and finally we have shown our results. So this is the basically. So in how we can see it in our view, like that we can think that like in the news articles or let's say in the social media, whenever we do something, whenever we upload something, or whenever someone others upload something, how they are get most hit. Obviously not the video, not by the image. Yes, image and videos are important, but also the taglines, also the captions that we give, that get more attractive. So in that a domain, it is very important what type of captions we are generating. And it is not always possible that everything is generated by human itself, right? Because there are some networks where continuous generation of upload of images and videos are done, so that for the popularity on the and then the flow in the network. So they use different type of tools, captioning tools, AI tools, so that the captions can be generated automatically. Okay, so I will come where what are the applications there, we'll come to that. But these are the overview. Now, quickly, just in few slides, what is artificial intelligence? So, do you know AI is used to generate captions for images and videos you will see online, enabling accessibility and creating interactive media experiences. So in the YouTube, nowadays the CC has come, right? There you can see that subtitles, right? Closed subtitles that mostly are generated by this type of AI tools. No one sit and actually create them. So these subtitles are basically they are taking from the audios. Sometimes there are other things where the captions have been generated for the YouTube videos. That not only YouTube, other videos on the social media. These are mostly nowadays are generated by the AI itself, not by human are creating. Human, if it is personalized, if it is my personal account, then I will do it. But if it's a social, it's an account like public account, like let's say some company is doing, then and they have to do every day, let's say 10,000 uploads they have to do, so that their market will go on. Obviously, people will not sit and do it, and if someone will doing, who will verify it? But they will rather more rely on the feed of the AI tools. So introduce AI as a transformative technology that is revolutionizing how humans interact with digital media, particularly in image and video captioning. Mentioning it widespread, used in everyday life. AI is used automatically to generate captions for images on the social media, help blind users, so accessibility as well as entertainment. Help blind users interact with visual content, generate descriptions for video content, enhancing accessibility and engagement. So how it help the accessible peoples? Basically, if there is a video they cannot see it, or there is an image they cannot see it, it will generate a caption for it and it will speak it out. So obviously, if they cannot see it, but when they hear it, they will understand what is actually going on. Now, examples of AI in action is in social media like Facebook, Instagram, Twitter, as use AI to automatically generate caption for images to make them accessible to users with the visual impairment. Next, entertainment. YouTube employs AI to auto-generate video captions. There are huge applicability for it, improving accessibility for deaf and hard-to-hearing audiences. Healthcare. Obviously, healthcare has also have a lot of places where this captioning, AI-enabled captions are used. AI-generated captions are used for medical image analysis, helping doctors to interpret radiological images by providing quick and descriptive annotations. So this is the quickly what is AI and how it is used. Now, definition of AI, I will say, AI simulates human intelligence in machines, enabling them to learn, adapt, and perform tasks that typically require human cognition. So obviously, intelligence in a machine, but they learn, they adapt, and they perform the tasks that actually take a lot of hard work for a human being, and they try to mimic like a human can perform that work, but not exactly how the human will do it. Key concepts. So learning, reasoning, perception, and adaptation. So what the learning says, adaptability to require and apply knowledge. Reasoning is logical decision making based on the given input data. Perception is processing sensory data. Like whatever sensory means, not only just normal sensor, it can be images also, sound also, text also, or it may be some sensor from accelerometer, gyroscope, or anything else. Anyway, in captioning, we don't go for that type of sensors, but that doesn't mean that perception can be from anywhere. But in captioning, we always look for images, videos, or or audios, or images, videos, audios, or text. We look for that. Like why else in text also? Like when there are news reports. In the news report, there is a part called not only the image and video. There is a part called textual part. There, that is also based on both the textual part as well as the image or video. The final caption is made. Especially this is the special part for the news image captioning or news video captioning. In normal image or video captioning, we go for only the image or the video, but in the news image captioning or video captioning, we used to have to consider the textual report that is given submitted by the for that particular news. For the news that are called news articles. So news articles have its own image or video as well as the article. So both are considered to generate the captions. Application: voice assistants like Alexa to complex autonomous systems like self-driving cars. Now, evolution of AI. So, as a history, 1950s, turning a groundbreaking question: can machine think? Lead to a turning test. 1960s to 70, emergence of symbolic AI and early expert systems. 1980s, shift to knowledge-based systems, like where actual the AI in rule-based AI has come. Limitations due to computational power. We don't have high computational power as well as storage power at that time. 1990s to 2000, machine learning has come up, and 2010 from 2010 onwards, deep learning has come up along with the NLP, vision, and gaming. So here we need the vision as well as NLP. These are the two very important parts for captioning. Without that, the captioning cannot be done. So a vision part, that was the image and videos or audios or maybe that. And for NLP, we need the text part. So how to generate the caption, how optimized and good captions can be generated, that will come from the logics of the NLPs. Key milestone: IBM Deep Blue defeating Casper in 1997. AlphaGo victory over the World Go champion in 2016. The future trend: integration with quantum computing for advanced applications. So nowadays you have seen that a lot of proposals from different places are coming for making quantum labs, for doing research in quantum, right? Because in the world people are working on quantum. So also our country also want to work in the quantum computing. And integrating that with the AI is, we see quantum computing earlier was there, AI was there, now they want a better intelligent quantum computing. So that is called AI with quantum computing. Now, how it impacts the societal impact: transforming industries such as healthcare, finance, transportation, and entertainment. So there is a wide range of use of AI there. Personalized in daily life, for example, recommendation or on streaming platforms. Economic effects: automation reduces the cost and increase efficiency. Now we know, like earlier what happened, this robotics, right? In robotics has been used in big industries, and obviously then some AI has come so that they will not be just rule based, they can also take decisions. Now we use AI in our phones, in our cars, in our washing machines, every smart things. We in the smart homes, we are lights are smart or temperature control. They are smart. There is smartness is there with gesture control. Nowadays, if it's a smart home, all the light, TV, washing machine, everything is just controlled by your gestures. You don't have to do actually say, or either your audio or by your gestures. So these are the smartness we have come through the AI. And obviously, when AI has come, this is the application from the user point of view. Now, from the industry point of view, when we have a good tools, like you have heard about ChatGPT, right? Earlier, it is very difficult to write something which is grammatically correct, right? You have to think of different tools. You have to do it. But nowadays, most of the people use ChatGPT to get a grammatically correct, because ChatGPT is a language tool. So if you think you can do other things, it is difficult. But as a user language tool for the grammatically correct to write a letter or for some notes, it will be very easy to do it from him. We don't have to take help from other people. So obviously it reduces the cost and reduces the manual cost as well as the increase efficiency. The new market emerging and creating jobs in AI development and data management. So nowadays, I think in LinkedIn and not only that, in many other places, there are mostly we see the lot of vacancies for AI development, for ML developers and all this thing. Earlier, it was like particular based on languages like Java or something like that. But nowadays, it is like languages will come later on, because whatever language will require, you will have to do. But you should know the AI development. So lot of vacancies for that. Driving force, exponential growth in computational power. Obviously, computational power and storage capacity has increased. That's why we can have able to adapt the AI nowadays. If it has not been exponentially increased still now, then we are 20 years back. We cannot do anything. Proliferation of big data through IoT and digital platforms, advanced in algorithms such as deep learning. So obviously, use of IoTs as well as the digital platforms help to capture a lot of data. That is what we required. And based on the data we learn the systems. As the system learn, they become intelligent and they process finally. Now, key components for data, algorithm, model, and infrastructure. So data, obviously, we got, this is the foundation of all AI, because without data, we cannot do any machine learning, deep learning algorithm. So structured data, unstructured data, semi-structured data, whatever it is. Data processing, so for cleaning, normalization, augmentation, feature engineering. So this pre-processing is the part that I said, even in the last lecture also, I said that after capturing of data, first thing we have to do is the pre-processing. Where what we do is in pre-processing is cleaning, normalization, augmentation if required, feature engineering obviously required. So cleaning, normalization is required, feature engineering is always required, augmentation if we required, kind of thing. Algorithms, all these ML/DL algorithms that we use to determine how AI systems should process the data, including regression, classification, clustering, or reinforcement learning, or adversarial training, and all other things that we required. Models, then representation of relationship with the data. So what type of models we will take, what type of activity we want to do, what the output we need. So based on that, models will be chosen. What is the size of the data? All this will depend what type of models we'll choose. Now, infrastructure. So obviously, it is GPU or TPU for computational efficiency, because normally CPU based is there very less. If it is a really a real-time project, it is never possible. It is just a student project, maybe it is possible. But in really real-time projects or the projects that are running in industries or like that, there it is not possible that you can actually run these algorithms in the CPU-based system. Next is, obviously, you can go for distributed system for scalability like Hadoop and Spark, that are always there. Quickly, categories are narrow AI, general AI, and super AI. Super AI is like beyond human intelligence. We have just, it is in future. Narrow AI are focused for particular application. General AI, we always say that it will actually, it will have an intelligence like human or near like human. But it will be currently non-concept. But still, we do not get such type of general AI till now. It is also still in research. So machine learning, again, it is a subset of AI that is focused on building system that learns and improve from data, improve itself from data. That is the what is called ML, machine learning. So machine should learn from that data and improve himself. So categories are supervised learning, unsupervised learning, and reinforcement learning. So supervised means training from the labeled data. Unsupervised means training from finding patterns from the unlabeled data. And reinforcement means there are rewards and punishments in the dynamic environments, and based on that it will learn. Utility is either prediction or classification or anomaly detection or pattern recognition or some decision making. Something we have to do some utility out of that. Key algorithms. These are some algorithms that are given. There are a lot of algorithms. Some like algorithms of regression, clustering methods, or decision trees, support vector machines, or DNN, CNN models, GAN models, and all we will come. What will be relevant to captioning will come later on. Now, quickly overview of what are the technologies for DNN has. DNN is a specialized bunch of ML. Now, ML is a specialized bunch of AI. DL is the specialized bunch of ML using multi-layered neural network to model complex patterns. So that means there will be layers, and based on the layers, some processing will be done. So it is a multi-layered neural network. So it obviously there are neurons are there. So it's a multi-layered neural network. Now structure of the neural network is input layer, so that receives the data. Then hidden layer, multiple layers, labels of hidden layers perform transformations via weight and biases. So that will actually do the performance. Whatever, how to capture the non-linearity, what are the things will actually are important, what is foreground, what is done, all these things basically actually happen in the hidden layers. So there are multiple layers of hidden layers. Now last is output layer, so which actually does our utility, that is to produce predictions or classification. For what we want to utilize it. So for the utility, it is used the output layer. Now what type of networks we have for in the DNNs? So we have, let's say, CNNs. For basic is CNN, right? Next, so CNN is convolutional neural network, which you already know. It's been very old technology. So it has already been, for many years we are reading it. Now apart of that, what we have recurrent neural networks. That is a sequential data. So just CNN are not only for image data, but it can all type of 2D or over that data normally are used for the CNNs. So if it is 3D data, then 3D CNNs will come. As you said in the last lecture, I said about 3D CNN. So 3D CNN can come if it is a 3D data, like if it is videos. So image or video data are normally used for CNNs. So if the time series data, normally we go for RNNs. RNNs have LSTM and other models also. So sequential data, or where the data has some time series or time dependent. Generative adversarial network. So it is helping. It's in short we call GAN models. They are for data synthesis, like regeneration of, let's say, image restoration. Earlier, before AI also, we have in computer vision we have used image restoration, right? So what we do, we actually regenerate the data, regenerate the image, right? So how we'll do it? So here we use the model that we use is called the generative adversarial network for it. But this is not the limitation that it will only do image restoration. There are huge lot of applications of GANs are there. So image, we'll see a lot of application of GAN today, here and in the next lecture also. Next is visual transformers. So visual transformers are the advanced model for the CNN as well as the attention model in a combination, which has give a very good representation of visual data. So visual transformers are nowadays are widely in use and in research also. Next is transformer network. So again, the RNNs and LSTM we have now also we used, but again in research nowadays what is widely used and widely in talk is for sequential data is the transformer network. Finally, we have attention network. The attention network means the network where which is used to focus in particular places. Let's say there are 5 people and all are in the background, but the main people, someone is doing some work, and we have to focus on that particular person with his facial expressions. So obviously we'll use the attention network on that particular person, so that should be the main focus, and others should be treated as a background. Otherwise the machine cannot understand. We human, we know that we have to focus on that particular person, and others are actually non-relevant because we don't know them, but the machine cannot understand that. So for that reason we have to design the algorithm in such a way so that the attention in our code, the attention will focus on the person we know, and for others we will not give an attention. So the machine will understand that since the attention model is only on that means that person is the foreground, others are background. Now the role of big data in AI. See, without data, as you said, without data there is no way we can do anything in AI, because once the data has a huge amount of data has come, then only we started to learn from the data, and once we learn from the data, we are using it in many places. So why big data? Essential for training large scale AI systems, provide diverse high dimensional data sets. So high dimensional, why it is? Because a lot of features it gives. If it is give limited features, then what will happen? It obviously the learning will be limited. Not only the size of the data, also the amount of features is also we need. Then so that it can learn anything from that data. Almost all the things can learn from the data. That is important. So not only the size of the data, but also high dimensional data set is also required. Now, source of big data is social media. So social media has huge amount of data. But the only problem with that is mostly are unstructured. Yes, there are structured data are there, but not all the data, and maybe 30% or 40% data is structured. Rest are all unstructured or misclassified, or their data is noisy. There are a lot of they are not properly structured data. I will rather say like that. So that is the challenge. Otherwise, social media is really a good source of data for AI. IoT devices like let's say smartwatch, smartwatch, smart belt, and our smartphones. Okay, we are always using them. They are always active, and they're collecting huge amount of data for all the activities we are performing. So this data is actually going to the servers by different apps or and the Googles and all that other things, and obviously they are as a source of the for input for the AI models. Then online transactions, public records, all these are also are the source for big data. Challenges: ensuring quality, avoiding bias and noises. As I said earlier, there are a lot of noises are there. There are a lot of misinformation there. There are a lot of unstructured data is there. Storage and computational efficiency. One is obviously computational efficiency. When we have a huge amount of data, we need GPU or TPU based servers, as well as how to store them, so that we need then like huge amount of data storage. Role of computer vision. So enables machines to interpret visual data. So we know computer vision is always used to interpret images and videos, like object detection, facial recognition, autonomous vehicle, etc., etc. There are a lot of more. CNNs are used for feature extraction and classification, like YOLO for object detection. There are many models. These are just an example. Now, NLP is a very important part in AI in captioning. So we are also quickly discuss the NLP. So NLP is to understand, generate, and interact with human language, playing a important role in translating visual data into coherent textual description of captioning tasks. So basically, we have to always tried the captions should be generated in such a way so that a human can understand easily. Not in such, or rather we'll say in a human-like captions we want to generate. So NLP is basically a technology that is used to generate, understand and interact with the human languages. Now obviously then we have to play with the human language itself so that human-like words can be generated and it can be made in the sentence. So that's why NLP is a very important part in captioning. So what it does is text generation, semantic understanding, and sequence-to-sequence modeling. So text generation basically convert the features from the image and video to natural language to create captions. Semantic understanding means we should ensure the captions are contextually correct, relevant, and grammatically correct, right? Next, sequence-to-sequence modeling encode visual input and decodes them into meaningful sequence structure, sentence structure, so that it should be a proper, just taking the keywords. Like let's say we take the object names and we put it. Will it be a sentence like human make? No. We have to make a proper sentence. So we have to take the activities, we have to take the objects, we have to link them and make a proper grammatically correct sentence. So technology in use is basically obviously any RNN technology, RNN, LSTM or something, any sequential model will be required. Then transformer attention mechanisms enhance the captioning capacity by focusing on the relevant visual features and contextual relationship, because we have to focus on the particular thing, so that if a lot of things are there present in the visual data, then we will not take them. We have to make captions precise and correct. So in precise and correct, obviously. Yeah. You should raise your hand. You should raise your hand first. So you should raise your hand first, so that when when I complete the topic, then I'll complete one of the slides and I'll answer you. Okay.
Okay.
Just wait.
Okay.
Yeah.
Okay.
So the transformer or the attention mechanism enhance the basically use. Can you mute yourself? So where I am, yeah. So it will basically help to the focus on the particular part of the image or video, and where we can say that yes, this part is important and the caption should come from this part, not the other part of the image or the video. Now the pre-trained language models. So pre-trained language models are the basically, as I said in the last lecture also, that we cannot have everything in a one go. So obviously we use some transfer learning models that are pre-trained in from other parts, and we use them to fine tune in our data. because obviously if you start tuning from the scratch, then what will happen? It will take huge time or an amount of data to converge to where we get the optimized output. So obviously, I have no nowadays no one use from the training from the scratch. Always everyone use pre-trained models to and use the pre-trained model as a transfer learning to train our data on the precise data that we have. Now, integration of NLP and vision. So we have seen vision, we have seen NLP. Now, how they will be integrated? They will be integrated with the multimodal AI. So multimodal is multimodal. Multimodal means different type of modality we have. So one is text modality, and which is 1D. And there is vision. Vision is obviously 2D or 3D. So that means they are different. The modality of both of them are different. Now, systems that integrate visual and contextual data for richer insight. Because as I said in the news image captioning, news image is not only the caption generated the text, but also we take textual data. We take textual data as an article and relevant image and video. And then we integrate and finally we generate the captions. So key technique is image text embedding models, align images and text data into shared representation space, transformer architecture like Will BERT. So vision and language BERT. BERT is a very famous model in the language model. It's like one of the base models, I will say. Then CLIP, contrastive language image pre-training models. These are the very transform model already exists in the literature. You can direct, their codes are also available. If someone want to work with it yourself or with a student, you can directly get their codes in the internet itself. Application, generating captions from videos and images, answering questions like question answer sessions. Like nowadays we can see that when you chat, many of them are actually the human beings are not present on the other side. The machines give the answers. So answering questions about the visual content or maybe your answers also. So that type of things are also used for using the captioning. They use these models. Okay, yes. Can you ask me what you want to ask?
Yes. Ma'am, could you please elaborate a little on how a camera detects an intruder or a criminal that is answers?
So I see this. That is not part of this lecture, okay? Because today we are talking about video captioning. So what you can do, you can mail me. We can discuss something else because that is a completely out of different topic. You are saying. If you ask something related to video captioning, I can discuss because I have to time limitation and I have to complete the video captioning today. Okay.
Okay, ma'am. One more request, ma'am. Actually, during your previous session, I already mailed requesting to share the slides. So today also, I request you to please share the slides.
I have no access. So don't mail me. Actually, I have no access. Actually, okay. You can talk to the IIT BHU authority for that. Okay, because and anyway, I'm in leave. Also, I'm in Korea itself actually for my project.
Okay,
so you can I think you have been invited by some particular authority, right? Some mail IDs and everything. So please request them.
Yes, ma'am.
Okay.
Okay, ma'am. Thank you, ma'am. Thank you.
Okay. So next is tools and frameworks for AI development like TensorFlow, PyTorch, Keras. So Keras and first people use Keras. Then come the TensorFlow, a bit advanced of that. Now mostly the students or the developers use PyTorch for doing the AI ML programs. Model training is Google Colab. Google Colab, almost everyone who don't know how to use high performance computers or the servers, they all started with using the Kaggle on Google Colab. So this is the cloud-based training platforms. So AWS, Sega markets, the integrated machine services for model development. These are also present, but mostly these AWS services are paid services. But Google Colab is free. I don't know which are non-paid, but Google Colab or Kaggle are free. That I know. Visual tools, TensorBoard for tracking training progresses and analyzing model performance. Now, introduction to image and video captioning. So, first is what we do by captioning, right? The process of generating textual description for image or video sequence using AI. So basically, we are generating a small summary or a small description, textual description from image or a set of images also. Set of images can be, I can say, not a single image or a video. For example, describing a photo, a dog is playing with a ball on a grass. If you see a garden where the dog is playing with a ball in the grass, we can just tag it with this line kind of thing. So that tag lines are the sentences that we generate are called the captions. So image captioning, generating a single or multiple line textual description from an image or multiple images. Video captioning is explaining events or sequence of video, often including temporal context. Why it matters? Bridges the gap between visual content and the NLP, natural and the natural languages, enabling the machines to understand and describe multimedia content. So that is basically this is the technology which use multiple things, like captioning use both computer vision as well as NLP as a subdomain for the AI. Okay, so obviously there is AI, there is AI techniques, there are computer visions, and there is NLP. All these three minimum requirement for video caption. It's not like optional. It is a minimum requirement. Significance in AI is integrating computer vision and NLP into a single cohesive task pushes advancement in multimodal AI technologies. So obviously we have lot of advancement and lot of good things that are coming up in the terms of research in these directions. And if you are interested to work, there are a lot of open challenges. So I will show in the last slide, and also there are a lot of publications I have. So you can start working in that direction also. So why it is important? So main application is accessibility, as I said, like those who have visually impaired, those who cannot see the images or videos or the things which are nearby, we can capture them, and actually we can convert into some text and make them hear it so that they can understand what is going on in around. Next is content understanding and management. Like lot of images are there. We human become puzzled, but if we just cluster the images and make, okay, this is for this. This 1K images is for this. One or two line tag, we said all classify them in one line. Maybe for one word is difficult, so we cannot make them classes. But in one single line, we can classify them so that describe the nature of the things. So that will help a lot, because that will help when we search in a huge database. Maybe single word searching is always not useful. So maybe we need multi word searching, and then we need this type of tags, this type of captions. To make large scale visual data set searchable by associating meaningful captions. For example, searching sunset over mountains. See, sunset you will get lot. For mountains you will get a lot, but you need sunset over mountains. So that is not a particular one tag, right? It is basically a caption. So this type of thing where we need. So here, if you tag the things with captions rather than just a hashtag, then it will obviously be more useful. Now, organizations used by digital asset management tools to auto tag and short visual data. Enhancing user experience. So AI-driven captions enhances the personalized content delivery by streaming services like YouTube and others, advertising agents, and education also, because nowadays lot of online courses are going on, right? So there it is always ways to tag them, to summarize them. This captioning has been used widely. So accessibility I already discussed. So here is again we have written with the same thing, but I will not go in detail much of this. It's like screen readers, video descriptions for those who have the issues with that. So in the regulation standards, we have guidelines that or in some rules and regulations in some countries it was there that if your app or if your system should be robust, so that it will also include those who are the persons who have visually accessible visual problems. So in that we have to use this type of technology so that that app or that system get complete, because we have to we have to think of them also, and the rules also said that without that the government will not permit. So the laws like American with Disability Act and guidelines such as web content accessibility guidelines are mandate that the visual content accessibility should be included. So there, without captions, we don't have any other options. The platforms, Facebook AI, YouTube, they generate a huge number of text for images using captioning models. Now, real cases another is content moderation. So in content moderations also, many people like nowadays content moderation is a very good job, right? Many people, not only not nowadays, I'm saying last 10 years or 15 years, many people are working on it as a, even not, if not full time, then part time also they are working. So here obviously captioning helps a lot actually. So it identifies inappropriate content through the textual summaries of visual data, enhances the content filtering by analyzing both visual and the textual data. See, manually if you do, it will be take a lot of time. But if we have at least a preliminary level of sorting the things using based on the captions, obviously it will be very useful. Next is implementation, platforms like Instagram, TikTok, YouTube are the captioning combined with moderation. For the content moderation part, I'm saying, model to flag violations, benefit, reduce human labor in manual moderation, increase efficiency in detecting contextual inappropriate content. So obviously, again, everything is narrow down to that we have to decrease the human labor and we have to increase the accuracy. See, in human, what we have, sometimes we do mistakes when we are like in hurry and rush. But if you do an initial level of screening based on this type of models, this AI models, obviously the human labor will decrease. And when we have to do a smaller part of smaller data, even human also doing smaller data, they will do it more efficiently. Education and training we are using like e-learning platforms. There are a lot of online materials are there. So if that materials are summarized in few lines, obviously then it is very easy to search them. Then corporate learnings are there. There are automated captions help to create training materials for the recorded videos. Okay. Then multi-language support. Now the captions can be generated in multiple languages. So it is like, it's not like in at least initial level, you cannot have to, you do not have to go for the this particular language. In your language, you can also get the content. So what are the captions? These captions can be in this language. Okay, from this language, we can get the data. So these are also always there. Now, social media, where the boosting engagement. Now, given the captions become very lucrative. People, okay, maybe the image is not image or video. They will, because it will take time. So, how many videos, how many images they will see? But the tagline or the caption that is given is very interesting. Then obviously many people will start to look into it. Once they look it, then go look for the entire video and everything. So that is always boosting the engagement of the people in the social media. And obviously, when the people are engaged in social media, that means it is generating revenue for the company whose social media you are using, right? Now, content discovery. AI generated caption improves search engine ranking by providing metadata for visual posts. So obviously, there are content discovery means there are visual posts, and the search engine used to help. When they fail to search directly from the image data, they will search through the captions. So that means it is increasing the efficiency. In healthcare, we use like a lot of scan images we have. If they are summarized, obviously if they are summary of the scan images, we can easily shorten them, keep them properly, and when the doctor needs, they can also get the summary of what is there, what has happened in that scan images. So that is there. Apart of that, there are telemedicines are there where the captions can always help, because to hear, to know, to understand the things. If it is in a short, it is written there in a summary, then any people, not only the very highly educated or technical people can understand, any general people can also understand if it is given like that. And training and documentation, video captioning aids in the creating instructional material for medical trainees by narrating complex surgical process. In medical, actually, AI is used very much. Not only just captioning, I will say. In the last lecture also I said, in medical, we don't know because we are not a medical persons, but actually in AI is highly used in medical sciences. Similarly, in autonomous vehicles, is audio based, audio based, and first is we give command, that is audio. Next, it will read the entire environment outside the car. How many things are going and coming. So that they will capture, and then once they capture, they will make a summary out of it. And that summary is the textual thing that will either they speak out the summary or they will show the summary. But showing summary is also a problem. So they will speak out if they're interacting with the driver. But if it is autonomous, obviously that means they're driverless. If the driverless, still also it will understand and make understand the other system who's actually moving the steering. So that means in autonomous car, obviously this technique is highly used. Now next is entertainment and media. Here also entertainment, as we are discussing long time, that entertainment media, that means this Twitter, this social media, all are the platforms, Netflix, then Amazon Prime, and all this, they use subtitles, they use captions, they use classification, they use categorize the movies and the dramas. All these things they use global captioning method for them, for generating the subtitles or subcategorizing them. So it is widely used in entertainment and media. Now the technologies. Now we'll come to some of the technical parts. So DNNs that automatically learn the complex patterns in visual data, transformer and attention mechanism, realizing the captioning task by involving contextual understanding. We'll come in details of that. So what is the pipeline we'll follow is the feature extraction, then sequential modeling, and finally generation of the output. Is it fine still now? Because now we'll go for the technical stuff.
Yes,
okay, fine. Okay, fine. Now we are going for the technical things. So the evolution of captioning models, how the captioning models has come up. Initially, in earlier days, we used template-based approach. So what means the template-based approach? That is predefined rules and templates for generating captions are given. We don't predict it. That time we have AI, not the ML and DL are not there. Okay. So we have predefined rules like fuzzy logic. I said rule based. Simply we have some rules are there based on the captions are generated. So and there particular templates are there. So it is very like what are the you feel the this kind of sentence, you feel the objects, actions, and you place on that, and based on that generate a caption. That was in the earlier, like let's say 20 or 30 years back. I'm saying. Now with the deep learning era, obviously we can predict, we can understand, we can learn from the data. So now, but since why RNN required here? Because we will generate a sentence. The sentence generation is a sequential modeling. Data reading and understanding from visual data is actually we can do by CNNs, convolutional neural networks. But when we generate a sentence, we need sequential data. So sequential words will be generated in a sequence to make a grammatically correct line. So there we need the RNN models. So combining CNN for feature extraction, as I said, feature extraction from the visual data, and RNN for sequence generation for the text are required for generating the captions. Now the advance of this come the encoder-decoder architecture. So encoder-decoder architecture is basically popularized by neural machine translation adapted for captioning tasks. We'll come in details of the encoder-decoder architecture in the next few slides. Now, apart of that, now these are the basic, either CNN plus RNN or encoder-decoder architecture. These are the basic things. Now, but how to focus on them? These are the basic, but these cannot do anything. Like it will not be very good because we human think in a very many different ways. So after that what has come is attention mechanisms. So what is the attention mechanism? Again, focus on some part in the visual data. Also, what other things we can do is the transformer models, transformer networks. So transformer networks will help to do parallelizing the processing, improving the performance and enhancing the scalability due to their ability to capture long range actually dependencies. Like if video is very long, the long range dependency it can capture in the form of text and images that were available. So that again to capture the long range, if it is required to capture the long range dependencies to generate a better caption, then transformer network will come. If we need to highlight in some part of the visual data, then attention mechanism will come. So on and above the basic models, we use these models also. So obviously attention mechanism and transformer mechanism are not used alone. It is always on and above. Either CNN plus RNN model, that are older one, newer one technology is the encoder-decoder models. Now encoder-decoder framework. So component first is encoder and then decoder. What is encoder does? Extract the features from the input data, simply. So typically use pre-trained CNNs like ResNet or EfficientNet or VGG16, any other models. Now decoder generate the sequential output based on the encoded features. So obviously from the encoded features we have to generate some captions. So that sequential model that sequence of output will be generated in a decoder, and that's why decoder use the RNN or LSTM or transformers, whereas the encoder use the CNN model for feature extractions. What is the workflow? Input image or video input, feature extraction via encoder. Encoder representations will be given as input to the decoder, that is RNN or transformer model. The output of decoder output the word sequence, that is the sentence or the captions. For example, I will say there is a base paper which everyone, those who work in captioning, either image or video captioning, first start with this paper, which is the paper was published by Google, and it is like a base model for anyone. It is called Show and Tell. So in 2015 it was published, and one of the first to combine CNN for feature extraction and RNN for caption generation, setting the foundation for future development. So anyone, if you want to do in research, in research or maybe some development in captioning, first start with this paper, I'll always say. Now, attention mechanisms. So it will help to enable the models to dynamically focus, not particularly every image or every video I cannot go and focus, right, as a human. So it will dynamically focus on specific part of the image or video frame relevant to the current word being generated. So whatever word I want to generate, based on that, it will give particular focus on it. Types of attention mechanism is spatial or temporal. So spatial means obviously different regions of the image or the video, and where it greater importance can be done, should be given based on the current word generated. Temporal attention, so current word generated means we have the ground truth captions, right? And see, this caption generation, this network is something different. As an input, we not only give the image and video, we also give the ground, while training, we give both the ground truth captions as well as the image and the video. So based on it will read both the video features are extracted and the features from the ground truth image, ground truth captions are also extracted. So these two features are kept in parallel, image features or visual features and the textual features. Now, based on each and every word or every feature in the textual, when we use attention mechanism, we give focus on or increase the weight of by using some attention mechanism in the visual data. That's all we do. Similarly, in temporal attention means temporal attention will come in videos, because there is only temporal is present in videos. Obviously, this focus on the most relevant frames at a given time. So there are, let's say there are 100 frames. We cannot give focus on every frame. Every frame is not important to us. So which frame we will give important, which we will prioritize. So that we have to do. We can do it using temporal attention. So extract features using CNN. Attention weight are computed for each region or frame. Caption generation aligns with the attended features. So again, it is from the show and tell. So attend and tell, it has been taken. Now transformer-based models. Now we come to the a bit advanced. So from encoder we come to transformer-based models. So what is the key features we have? Using self-attention mechanism. So if anyone has seen the architecture of transformer, then you can find that the transformer has, apart of this CNN models, CNN layers, they have a extra part is called self-attention mechanism, which will go and loop so that it will enhance the features and able to focus on particular regions. So this self-attention mechanism for understanding the relationship between the input tokens, that actually help to focus, give extra weights to the important parts. Replace sequential RNN or LSTM for parallel processing. So here, since it is already focusing and doing the work there, so we can actually replace here the RNN or LSTM part here. Now workflow is encoder, decoder, and positional encoding. So encoder obviously encode the visual features. Decoder will generate the captions using the embeddings and the self-attention, and position encoding will maintain the sequence order without any recurrence, because sequence order is also required, right? We have to, if we just choose this is the activity, this is the object, it will not work. Finally, we have to make a proper sentence. So sequence is also required. And if it's a video, then the events has happened in a sequence. That is also important. So position embedding is very important when you use transformer-based model. What has happened in LSTM or RNN-based models, they will come one by one. They will not come together, all the things. So there obviously one part is over, to one part output is also come. But in transformer-based model, we have a special part called position encoding, so that we can remember while processing what has come earlier, what has come later. For example, is VITs has demonstrated superior performance in image recognition task and now being adapted for captioning. Image captioning transformer models like image transformer use transformer instead of RNN to generate captions. These are the two very popular technology. I will say technology rather, because earlier it was a paper, but nowadays so many people use them to do their work. Now they become a technology now, both VITs as well as the image transformers. Now pre-trained models. So for vision language model, pre-trained vision language models, what are available in the literature, I will give an overview. Not only this, many more are available, but these are popular one, most popular one. I'm just saying their name. Okay. So overview is pre-trained models like pre-trained on large scale image dataset. Utility is fine-tuned for specific captioning tasks. So first take pre-trained model, use transfer learning, and for the particular task, for the particular captioning task, see, captioning task can be many things. You cannot say our generic system which can caption for everything. Obviously, they will get diverted. So let's say you want to do captioning for particular some healthcare device. So particular for if that's for healthcare things, obviously if the keywords are related to healthcare, then it will get more accurate, right? So take a pre-trained model, use transfer learning, and then use that smaller data set where you want to do captioning for training it. And then finally you get the good output in the testing time. Popular architecture is CLIP, Contrast Language Image Pre-training, developed by OpenAI. OpenAI is again a very big standard, I will say, in the deep learning, in the era of deep learning. The models finally they give are always used as a benchmark, mostly used as a benchmark, I will rather say. So jointly learns image and text representation. Then BLIP, that bootstrap language image pre-training, unified framework for multiple image vision tasks by leveraging a bootstrap method where image and text information mutually reinforce each other during pre-training. So if I say in single word, obviously it is very difficult to understand because these are entire papers. Okay, but what the good thing is about them is just not the paper. A lot of articles are present if you just give them a lot of article and summary article for them will be present in the Google. Not only that, because these are all very popular benchmark pre-trained model architectures, so their codes are available. You can directly take them and use it. Recent models the code will not be available, but for them the codes are also available. So that type of models only I have written here. Lava, so large language model with vision, so combines with GTP. With visual encoding. Advantages: these pre-trained models allows for zero-shot learning, meaning they can generate caption without needing task-specific label data, improving scalability. So what is mean here? Zero-shot learning means if in case, let's say you want to do healthcare, okay, and you don't have any actually specific data set for that, still it will give some result. That's why it's called zero-shot learning. These models generalize well to new domains and tasks with minimal fine-tuning. But if you have, it is very good, then it will adapt easily and generalize easily in the new domain and with minimal fine-tuning. I hope now it is clear. So it will work, but obviously when we say zero-shot learning, that means the accuracy will not be very high. But if it's minimal fine-tuning, it will give it will generalize very good. Now video captioning with RNN and LSTMs. So what are the challenges in video captioning? We have video content dynamic temporal information, which makes it harder for traditional models to handle dependency across frame. So when it's called video, that means multiple events, activities haven't happened, and the activity cannot be captured in first few frames. It might happen. There are activities that should be captured over the frames till the end. So that means the temporal apart of visual data, spatial data, we have to capture the temporal data also. So just not the spatial dependency is sufficient for that. Redundant or noisy frames may confuse the model, reducing the captioning accuracy. Now it happens, there are blurs. Spatial blurs are there, obviously that is for lighting effect, camera effect, then focus effect, then angle effect, these are there. But in temporal blur is there. You know the hand is moving not properly moving and the capture was not taken in right time. So obviously there is a blur around the hand, and based on that all the things will be blurred there. So obviously the temporal blur, when it clump, it will make the entire frame clumsy. So these type of things we have to handle extra. Now solution is with RNNs. So process sequential frames for temporal coherence. So RNN will take which are the important frames, which are not important frames, and coherently it will make the choose the frames and process them, generate captions word by word, and based on that they will generate the captions. LSTM and GRU, which is gated recurrent units, are introduced to overcome the vanishing point problem, vanishing gradient problem, allowing the model to maintain long-term dependencies over the course of the video. So there is an issue called vanishing. This is a very basic issue that is called vanishing gradient problem. If anyone has worked in the ML or DL, they know this thing. So we have to fine tune the models. We have to use different non-linearities. We have to use different regularizers so that this issue should not come up. So LSTM and GRUs are the very good models for in that case they automatically handle this type of problem, this vanishing gradient problem. So that while capturing this long-term dependency should not go to become the non-linearity should not become zero. They should be able to capture it. Now use of LSTM or GRU, the RNN or LSTM capture sequential dependencies, making them ideal for video captioning. They can effectively process the frame sequences in videos and output relevant description. These models are trained to generate descriptions word by word, taking into account both short and long-term dependencies. This is short and long-term dependencies. That is the important part. So in videos, which we said just dependencies, it will not be meaningful. So, but we have to always think of both short and long-term dependencies, because some activities are really take long time to perform. Some activities are really short time, but the short-term activities are easy to capture and immediately we can get the output. But if the long-term activities is the important one, we cannot miss it. Now, different attention mechanism when we do video captioning. So one like temporal attention, as I said earlier also, temporal attention, what will do, it will actually give importance to the important frames, and so that the other frames which are non-important can be neglected, or the weight for the frames will be very less. So that we can do by improving the coherency, by ensuring that the generated captions are contextually relevant. Now, spatial attention is always the spatio-temporal attention, both attention just not on the sequential data, but also on the both spatial and temporal. So in combined we can give, and obviously that will give more, that will give focus both on the regions within a frame as well as the over the frames together. And obviously that is more meaningful, just giving either separately spatial, separately temporal. If we give, that will not much, that will be meaningful, but not that meaningful as well as rather than if you give a spatio-temporal attention, if you make a model which you can give spatio-temporal attention. Now example is sequence to sequence, video to text. So this is again another, I will describe this how it happened. It is a very popular model. So this model integrates LSTM with attention mechanism to improve the video captioning accuracy. It learns to focus on relevant frames and generate descriptions based on the sequence of video clips. Advantages: improve captions coherency, relevance by focusing on meaningful content. So sequence to sequence, video to text, S to VT is a very it is again I will say a kind of base model for video captioning. So that actually basically help to, if you give, now for this you will give directly pre-trained models for it. You don't have to actually run this code, because this is so popular, so everyone use so much that it's direct you will pre-train. So you have to just give input and you will get some output. So these basically use this does not use the transformer model, because this is very old, not very old, maybe 10 years old, is also in deep learning is older actually. So they basically use LSTM based and CNN based models for generate the video captions. Now, what are the metrics? So captioning has a bit different metric from what we have earlier. We have seen for classification or regression and all this things. It has a bit different metrics for estimation or evaluation. So the metrics that are used here are basically, one is called BLUE, bilingual evaluation standard. Then next is ROW, so recall oriented. For one is for recall for BLUE, ROW, CEDAR and METRO. These are the four. So these four basically used for the what I'll say, they are basically used for the type of captions generated, the quality of the captions generated. Earlier, when we do classification, we say this is this or this is that. When we regression, we do what is the value. So that's why there with in there the thing is used to come is accuracy, how accurate it is. But when we generate a caption, we cannot say how accurate it is, because a sentence can be written in many ways, right? So we cannot say that this is the accuracy of the sentence. This is not very difficult to say. So rather we describe in a different way. So we evaluate in a different way. And that different is actually captured by the evaluation matrix is blue, row, cedar, and meteor. So what blue does is measure the n-gram overlap between the generator and reference caption. So what are the GT captions and the generated caption? How much overlapping is there? Then Rogue says that evaluates recall n-gram in generated caption. How much recall is there? How much recall is how much good it is, how much understandable it is. Cedar is evaluate the consistence between the human annotated captions. So if a human say how he will say generate the caption and how this system has generated. Meteor says consider the synonyms and stemming of for flexibility in evaluation. If this in this type, let's say you use a English word, let's say help. It should be help or assist. What type of synonym should be used so that it will be more meaningful. So this type of metric, these are the popular metrics that are used for in image or video captioning. Now qualitative metrics, human evaluation, improving the assessment of fluency, accuracy, relevance of captions is critical in understanding the strength and weakness of the captioning model. Now limitations is data requirement. High quality labeled dataset are essential but expensive and time consuming to create. Obviously, for captioning, we go for supervised learning. We don't go for unsupervised learning. If you want, you can go. Someone can go, but obviously the accuracy will be very less. So we don't go because we don't. From an arbitrary image, it's very difficult to make a sentence out of it. So we always go for supervised. So here we don't have described supervised answer. This thing we have not come here. We directly assume that we are going for supervised learning. Now, so obviously, if it's supervised learning, that means we need a huge amount of data that are labeled. Next is model complexity. So here we are handling images, we are handling videos, we are handling text information. And if it's multimodal, some nowadays some people also involve audio data also. So that means lot of multimodal things are there. At least two modals are there, the text and image data. So that means deep model requires significant computational resources as well as storage. Bias in dataset, models inherit biases present in training data. That is always present in any deep learning models, and there that biases can be present. So we have to handle it cleverly. Context understanding, difficulty in understanding the cultural and situational nuance. So we have to understand the context also. Future directions, developing lightweight model for real-time applications, improving contextual and cultural awareness. So if we have to generate captions in the real time, let's say some live cricket match is going on and you have to generate captions for it. Human should not be announces rather than some automated system will be. That means that the model should be lightweight, right? And very precise, very accurate. Because any comment has been made in a live match, obviously that will be broadcasted to everyone. So we have to be very careful, so it should be model should be sophisticated as well as it should work in real time. That means it should be in lightweight also in nature. But in earlier we said that it takes a lot of computational resources. So obviously there are still lot of scope to do research how these computational resources can be minimized and the speed of the model can be increased. Now some of the core dataset, if someone want to start working, for them it is there. There are many other datasets specified. But if you just want to start with image or video data sets and want to do some work on it or with your student, then you can start with this. Like COCO, common object in context. It's a very big and good image captioning data sets. Flickr 8, Flickr 30, 8K and 30K are also very good data set, but they are smaller in nature. Video captioning is MSVD, Microsoft Video Description datasets. These are annotated video clips with description. UCook2 is also for cooking videos annotated with the captions. Importance of datasets, these are benchmark datasets widely available. You can just directly download them. They are diverse, they are annotated properly, there is mostly noise free, and they are very robust. and serves as a benchmark for evaluation your work. Now we'll come to the any doubt up till now. Now we'll come to some of the models quickly, like these two models, how they are working step by step. Okay, so let's describe two models. One is show, attend, and tell. That is based on the CNN, RNN based, and the image transformer, that is transformer based for image captioning. Similarly, we'll also quickly describe two video based models for video captioning, and we'll then summarize the talk. So basically, it is by the, as we say, it is by the author Zhu and et al. So basically, they introduce the concept of special attention in image captioning, because when we do captioning, we cannot describe each and see. If you see an image even if you click within a room, you will see that at least 30 or 40 objects will come together. So we cannot when we have to write a caption in a one line, we cannot write on each and every object. So we have to give special attention. So they are the first who actually they introduce the concept of the special attention in the image captioning, and allowing the model to focus on specific regions of the image when generating each word in the captions. So model components: encoder for pretend CNN, like VG16 they have used for feature extraction. Then attention mechanism they have used to focus on them, so they make their own attention mechanism. Then finally they use RNN model or LSTM probably they have used to generate the caption word by word, condition on both the image features and the attended regions on the features. So how step by step input data? So they give the input data in the pretend VG16 or inception to extract the features. Then they use attention model. So the spatial attention layer that assigns the attention score to different regions in the image. So attention scores are computed by comparing the current hidden state of the RNN with the feature map. The attention mechanism decides which part of the image should contribute to the next word in the caption. Because from the image data, we have to generate a caption, generate a word. So which data should be used to generate the word, and which part should be neglected and not be used for the generating the word. That attention score, for that reason, when we give some attention, they will generate some score. If the score is high, obviously they will use for generating the words. If the score is low, they will not. Next is decoder model. Now decoder model is finally actually use the sequential things. So the attention weighted features and the previous words in the caption are used as an input to the LSTM or the GRU network, which predict the next word in the sequence. So sequence generation, how it done? The model generates one word at a time, and each word condition on both the previous word and the attention weights. So attention score that you got and the previous word generated. Based on that, is finally predict the new word. So caption generation, the process continues until the model generates end-to-end sequence token, indicating that the caption is complete. So finally, when the end of the sentence will come, it will say, oh, the caption is generated. So advantage and challenges. Advantage is focus attention. This is the first time the captioning they have used for focus attention. So next is improve visual understanding. So since focus attention was there, that means the understanding has been improved. So it has focus on particularly the attention shows the model to better understand the complex images with multiple objects, leading to more detailed and accurate captions. But challenges, computational efficiency as well as limited generation. So because it's a very earlier model, so it is a very heavy model. And limited generation means the model struggles with images containing unfamiliar objects or rare contexts. So the ground truth that is made for them, they have used are restricted to few objects. So that's why unfamiliar objects, they cannot just skip it because they don't understand. They thought it is not useful, but they may be useful in the test time. So these are the challenges, because this is very, again, I'm saying lot of work has been done after this. So these, I will not say that you can start from here, but don't think this is the research problem still left, because many work has been done after this. Now image transformer. So it is the authors are Chen and et al. So key idea is the main transformer uses the pure transformer based architecture for image captioning. It treats image captioning as a sequence to sequence problem where both the image and the text are processed in a sequence. So they use the text as well as the image in a sequence to sequence. Now for them, what they have done is feature extraction. Unlike traditional CNN, they use image transformers. directly apply on the applies our transformer to image patches. Then transformer encoder, then transformer. The transformer had two parts. I already have discussed encoder and decoder. Now encoder, what will do? The encoder will take each of the patch and process it and get some features out of it. Decoder generates the caption based on the features and the prior context. Prior context is the prior word generated. So step by step, image pre-processing. First, you have to divide the images into patches, and so that you will get the tokens from them. Next is and do lot of other pre-processing techniques that are required for filtering or normalization or generalization are required. Next is image encoder. This encoder is basically these patches embeddings are passed through the transformer encoder. The encoder consists of multiple layers of self-attention, which allows the model to capture relationship between the different patches of the image. Now, in an image, we have different patches. We take each of the patch, and for each patch, they process it and try to map with the other patch to get the meaningful information and the relationship among them. Now, as I said earlier also, when we come for the transformer, we need positional encoding. Because here it is not, it is really not a LSTM or sequential model, but we want to use it as a sequential model. So position input. So, but if we give the positions, now once the position associated with them, we have no need for sequential model, right? We can use the position, the embedded position values as a sequence. So that's why the position encoding is always comes here. Since the transformer architecture does not inherit process sequential data like RNN models, position encoding is added to the patch embedding to retain the information about the spatial location of each patch in the image. Okay. Now, transformer decoder. The decoder processes the image patches along with the previous word in the caption. It generates the next word in the caption by attending both the image patches and the previously generated words. Finally, the caption generation, the process continues word by word until the end of the sequence token is generated, the end of the line. The transfer ability to process all the tokens in parallel, enabling the efficient and high quality caption generation. So obviously, transformer are much better because the attention model are there. And the only problem with them was there's no sequential model, so they are using position embedding. So nowadays, mostly the research are going on in the transformer models in the image captioning domain. Quickly, advantage is parallelism. Obviously, multiple patches. The multiple patches we are taking multiple patches of images and they are all being processed in a parallel. Better representations because they are patch. So patch has a lot of features can be extracted from the patch and they are very focused and specific. Scalability. The image transformer can scale to large data sets. So obviously they are much better. Challenges, high computational efficiency. Obviously this is also there are a lot of challenges in the computational cost. Data requirement, transformer tend to require large amount of training data. So transformer because we have to focus, we need a lot of training data. So supervised training for label training data. Now we come to video transformers. So for video transformer, we have again taken two models. One is S2VT, sequence to sequence, video to text, and another we have taken is video BERT. So these are the two very popular models. So we'll quickly. So one is RNN based model, another one is transformer based model. So we have taken like that. Now we'll quickly come to the first model. So first one is the S2VT. Venugopalan et al. has been described this thing. So okay. Now S2VT combines an RNN based encoder decoder framework with the sequence to sequence modeling. It processes the video frames sequentially, learning to generate captions based on the temporal relationship between frames. Now here we have to understand that not only for caption generation we need an RNN model, we also need something sequential to capture the temporal dependency over a video. It's not just an image, it's a video. So we have temporal dependency, right, to perform an activity. So we have to capture that. So what they done is here, they use this encoder decoder model as an extra so that they can capture along with RNN so that they can capture the temporal dependencies also. Now how it works is first encoder, for encoder they have components, the encoder, temporal LSTM, decoder, again another LSTM. So what they done is encoder is basically for feature extraction, that is CNN or VG16 or ResNet, something they have used. Then temporal LSTM network processes the frame feature sequentially. That is only do 1D data, but over the time to get the changes in the frames, not what special thing, just the changes. What is happening, they are not taking. They are taking what the changes over the frame, so that the special, along with the special activity, the temporal changes can also be captured. That is the work of the special LSTM. Next is decoder. So decoder is again, that LSTM is used for basically the word generation, that is a caption generation. So earlier the temporal LSTM is the extra one, because here it is not an image, it's a video. So we need to have to capture the temporal sequence over the frames. So that is the temporal dependencies over the frames. So that is why the temporal LSTM has come here extra. So again, this, okay, now we'll come in details. So video input, so you can use VGG16, kind of any network for extraction of the video, for extraction of the features, visual features from each frame. Then temporal sequence encoding, so each frame level features are passed through a LSTM, which processes the sequence of the frames and capture the temporal relationship between them. So I'm again saying it's a temporal relationship. We basically, this part is extra to capture the temporal relationship. Next is decoder, that is RNN or LSTM. So the decoder generates the caption word by word, conditioned on the visual features and temporal context provided by the encoder. So this is basically using, again, the like in the image, we are using the, based on the context, and the previous word will predict the current word. So that was happening in the decoder. Finally, the caption, end-to-end caption generation, when we get the end-to sequence token, we'll understand that the caption has been finalized, and the output caption will come up. So advantage is sequential modeling, action understanding. So both we have done, since we are using LSTM, so it will perfectly doing the sequence modeling. And for action and understanding, we have, if you use a good good encoder as well as temporal LSTM, then it can understand the actions properly. Challenges: frame redundancy, computational complexity. In captioning, this computational complexity is still an open problem. If someone can work on it, it will be really, I will not say there is no work, but still an open problem, I will say. And frame redundancy, when you come from video, it is always, anything, when you deal with videos, this frame redundancy problem always come, because which frame to select. Otherwise, we have to go for keyframe selection first as a pre-processing part. And once the keyframes are selected, then only you act. But again, that will again add some extra computational overhead. So either you add some computational overhead, or you go for go for frame redundancy problem. Now, next one is VideoBird. So VideoBird is again, the authors are Sun and Ito. So main idea is using the transformer-based architecture to process the videos as the sequence of frames, similar to BERT, process text. So BERT is, as I said, BERT is a very popular and very old model in NLP. So similarly used, they have done the thing, but they name it VideoBird because they are not just working on text, but they are working on video and text. So they name it as VideoBird. By leveraging a transformer, VideoBird can model long-range temporal dependencies and learn meaningful representations, both spatial and temporal features. So spatial features, temporal features. These are the two important parts, right? Because it's a video. And based on that, finally, a sequence of words will be generated in a correct grammatically form. The components are visual feature extraction using CNN models, then transformer encoder, transformer caption decoder. So transformer encoder will encode the both spatial and temporal here. So the learning the dependencies across the frames and the regions, and caption decoder will finally generate the captions, encoded captions from the features. So video input, we use VGG16, ResNet, some good models we'll use. Then we'll do some pre-processing on it, so that because it's a visual data, video data, so maybe we can tokenize the features, or we can do some keyframe selections. Something we'll do for pre-processing. Then transformer encoding will come. That will actually, the transformer will do and the encoder will process each tokens and capture both spatial and temporal relationship between them. The like way I said earlier in the image transformer, similarly it will do the patch wise, both temporally and spatially. I have not gone in details here, but there we have described the patch-wise images was taken. So in a spatial dimension, here it will do both patch-wise in spatial dimension as well as in temporal dimension. Be careful about that. And finally, they use again caption generator, like in image image transformer. Also, they have used similarly here the caption. The transformer decoder generates the caption word by word, condition on both visual and temporal features and the previously generated word. Now, advantage: powerful temporal modeling. It is much powerful than the only using the LSTM, because obviously the transform models are much more powerful than the simple sequential models. So powerful temporal modeling. The transform architecture allows VideoBird to model long-range temporal dependencies efficiently and effectively. Generalization: VideoBird is pre-trained on large amount of unlabeled video data, enabling it to generalize across various video domains. So when they have made it general, they have trained it over a lot of data. So now if you going to use it as a pre-trained model for your work, it will really good for any transfer learning method you use on it, and it is really good for you. So VideoBird, now we see 2019 to 2024 means almost 5 years or 5-6 years. So a lot of work have come on over it. So nowadays we don't say that we are going to do some research on VideoBird. Rather, we use it as a pre-trained model for our work, and then we enhance, do our own work. But these are now good as for pre-trained models. So now use a proper transfer learning model to use this pre-trained model in your work and start your work. Now, challenges is high resolution, high resource requirement. So transformers require large data and significant computational power for both training and inference. So obviously, whenever there is a transformer, high resource requirement is there. Even in image it is there, in video it is obviously more, because now it's videos. The videos have higher size, higher dimension, so processing will be higher, storage will be higher. Limited fine-grained temporal understanding. So in the initial phase of VideoBird, when it comes, it does not focus on the fine-grained details, like proper, like if you're doing handshake or if you're giving something, a smaller element to someone. So handshake also, both you are touching, holding your hands, right? And two people are holding hands. And if you're giving some small object from one person to another person, they're also holding hands. These are the small things, fine-grained details. They have not taken care of them. They are rather prefer to take bigger things, prominent things. So obviously after that, in this 5-6 years, a lot of work has been done on this dimension. So in video captioning, there are some ethical issues are there, bias and fairness. So AI models, including those for images, for video captioning, may have content biases. So in the result, the captions that reinforce stereotypes, misprint, marginalized groups, fail to accurately describe, like what else? So like the color based, okay, like sometimes like they make a comment like which is based on the color, based on the human colors, I'm saying, okay, or based on the based on something that we should not describe, but the captions are generated. So we have to be careful that what type of caption is generating. Next is we should be fair, like how the things are happening. What should I say? Is like there should be fairness in the model. That it should not be biased for particular things. It's giving really very good caption. For other things, it's not giving very good captions. So it should be fair on the domain where we are using. Privacy concerns. So it should not be expose some sensitive data. That's what I'm saying. It should not expose some sensitive data, right? So that we have to be very careful, because it will may lead to you in the developer who's developing the caption may be in trouble, because they are leaking the privacy, some sensitive data which are actually leading to a potential privacy violation. So that we have to be careful. Then misinformation and manipulation. So we should not, like the data is something else and we tag it to something else. It should not be happened. So that means we are faking it. So that comes from there the context of deepfakes comes. So what is my next talk is the deepfake. So from there the deepfakes comes. Okay. So that type of things are deepfake again is a controversy. But I'm saying if you do illegally, by intentionally and illegally you do the things, then you may be in a big problem. Accountability. So there is a need to clearly define accountability when AI model generates harmful, biased or inappropriate captions. So obviously you will be accountable if you generate something which is ethically wrong. So be careful about that. So these are the ethical issues you have to be careful. Open challenges. context understanding. Still now there are a lot of things, lot of videos, especially in the videos, content understanding is still a big challenge. So people have worked. I'm not saying people have not, or people have worked, and still there are a lot of scope to work on it. Temporal reasoning in videos. Video captioning models still face difficulty in reasoning about context, complex temporal dependencies and multi-stage events in videos. Understanding how actions evolve over time and the relationship to each of other is still in major hurdle. So temporal, as I say, the temporal reasoning or context understanding in the terms of video, there are a lot of scope. In image, I will understanding, lot of work has been done. I will not say there is no scope, but yes, many work has been done. But in video, there are still many scope. Capturing fine-grained details. People are still working capturing fine-grained details. So if you want to work, you can work on that, like emotions, interactions, small objects. These are place where you can work on it. Generation across domains, like you make a model and which is generating other models. So that type of nature still there, where you can work on it. Multimodal models now in not only the image and video, image and text, image, video and text, takes all three, or take audio also. So multimodal models you can make. There are a lot of scope. A lot of people are working, and there are a lot of scope still there left. Cross-modal transfer learning. Now you learn. Now when we have a pre-trained model, we take if you are working on video, we take a pre-trained model on which is already trained in a video. Here we are saying, let's say that is trained in text data, but we want to use that pre-trained model in a video itself. So can we use transfer learning for cross-modal learning? Can we do that? So you can work on this direction because the captioning is a very good place where you can use this type of pre-trained models, because it actually is a multimodal technology. Now, if you go for unsupervised, then you can go for zero-shot learning or few-shot learning. You can use them and explore them, and because vast amount of data and captions are available in the social network, but no, they are not structured, and lot of noises are there. If you can actually do something, this type of things, then you will get a lot of exposure over there. Explainability and interpretability. Obviously, this interpretable AI is nowadays very good in the market, and people are talking about it. So their video and image captioning are particularly highlighted. So maybe you can work on that direction. You can see on that. In AR VR, the captioning is used a lot of places, because obviously when you are doing AR VR, there are captions that are generated and they can be heard, they can be manipulated, they can be used actually. So AR VR is a very good place where captions are used. Multilingual and cross-language application, wherever we need multiple languages. So it is directly from audio to audio translation is not good. But if you can summarize it, and then the summary is a very short summary, and then the summary can be make understand to different languages. So that can be very useful. So whenever the multilingual or cross-cultural applications are there, captions are widely used. So finally, real-time captioning in live event is a really good place. But again, the computational efficiency is required. Personalized content generation, video captions are very much required. But again, where we have to be, whether if it's AI generated or if it's manually generated, we have to be careful. We should not leak any personal data or sensitive data. To summarize, final last slide. So we have described the AI-powered image and video captioning, which has we have discussed also the challenges, ethical biases and generalizations. We have also discussed the models that exist here, and we have described some of the benchmark data sets as well as the models that are very popular in the literature. We also discussed some of the open research problems. I also said that to what extent they have worked and to what extent they have left. So you may actually look into that, and in case you may think that you can want to work on it, then start with the basic model they have described. That will help you to do the base part. Once you can do the base part, you can also start doing the research. So the open challenges that I said, that are still there. I'm saying still means in 2023, yes, 24. Still these challenges are there till now. So these are the few publications that related publications of me with my students in this area. And yeah, So this is the, okay, I am taken 15 minutes more. So, okay, any questions? Yes, please.
Hello.
Yeah, please. Go ahead.
Madam, video capture, whether it is of similar type of implementation, image capture is similar type of implementation or anything else? Other technologies are applied behind that.
Capture means what do you want to, what do you want to do?
Means during the login process, the instead of character, the images are coming. So in a matrix, the images are coming, and we need to identify some of the objects. So these are scattered images, and similarly, the items need to be identified from the image. Let it be cycle is present in some cell, or some item, some person is present in one of the cell, and within
That
the
is called
time period,
reasoning.
identify the
That is
object.
called, yeah, that application is called reasoning. This application is captioning. So that is called reasoning. So you give an input, based on it will match on the object whether it's have or not. So that is called reasoning, and this is called captioning. It will generate a caption, and that will, the keyword that you will give, based on it will match. So that is also a complete domain of another, like, similar presentation, I will say, reasoning, image reasoning or video reasoning. There is a complete domain, a complete presentation can be done on that actually.
Okay, madam.
But again, the deep learning, machine learning things the intermediate things will come similar way, but output is different. Okay, that's what I'm saying.
Okay, ma'am. Yes.
Yeah. Anything else? Okay, then we'll take a break for let's start by again by 10 minutes. We'll start at maximum 5 to 10 minutes. We'll take a break and we'll start with the next one so that we can complete in time. Hello everyone. So let me start this session. Is there anyone who has joined new? So I'll skip the introduction parts because there's no one has joined recently. So we'll come to the technology part in that case. But wherever there's a repetition, then I will skip that part. So as I said earlier on the last sessions, not today's sessions, in case if you are interested to work on the technology that I am saying or the publications that I have shown, so you can see them. Most of the recent papers have their codes are also available. So if you search that paper and go for the particular link on that paper, you can see that the codes are also available. So you can explore them and work again and find some challenges on them and can extend it. There's always a scope for you to do some research on it. Now, it is an interesting topic, I will say, because it's a very controversial topic. And it has just come only maybe 2-3 years or hardly 5 years, I will say. Well, this terminology has come hardly few years. Before that, no one has known this thing. So what is this deepfake technology is? Deepfake technology basically leverages AI and deep learning algorithms to manipulate or create visual or audio content that appears real but is in fact fabricated. So simple thing, deep fake. So fake is coming from being fabricated. Why deep? Because the term deep fake is derived from deep learning and fake, so it is called deep fake, reflecting how these technologies use neural networks to produce convincing fake media, often involving faces, voice, or entire bodies. So it is a very challenging problem, right? We see that there are a lot of issues come when these celebrities or the known peoples, they're popular peoples whose face has been changed. There are a lot of agitations in the social network, in the news, and all this thing. Then contents has been replaced with something else. So all this type of incident used to happen earlier also. But now they have given a new name and bring all of them under the name called deepfake. And now they are more appropriate because the neural networks are very efficient. And this efficient network can actually fabricate very well. And this is not, this technology has not been bring by some smaller person. Okay, this is a very big group who are working on it and showing it how the fabrication can be done and how also can we prevent. So there's a very, very big, so smaller groups are not working on them. Normally very big groups are working on them. And they're saying that very big and very popular, very strong groups they are only working on it. And they are saying how to fabricate and how to prevent also. So let's start and let's see how the things are actually because there not much development has been done in this area, but still what are the development has been done and what the people have what these big peoples have done in it. Let's see it. So deepfakes have raised concern across various sectors, but they also have potential uses in the entertainment, education, and beyond. Understanding deepfake technology, its capability, limitation, and ethical implications is crucial in navigating the digital future. Now, what is deepfake technology? A deepfake refers to synthetic media, usually images, videos, or audio recordings, where person's likeness or voice is manipulated or replaced with someone else, often using deep learning methods such as GAN and autoencoders. So basically, autoencoders and GANs are 99% cases or obviously used in the deepfake, apart of using other things. So what is GANs? Generative adversarial networks. So earlier I said these GANs are used for image restoration, right? Here I'm saying these GANs are widely used in deepfake. So GANs involve two neural networks the generator and the discriminator, working in tandem to create increasingly realistic images, videos or audios. The generator creates fake data while the discriminator tries to detect the fakes, pushing both network to improve iteratively. So what happened in GYAN is, if no one knows, then I will just say it in a brief. It has two neural networks. The one neural network is called the generator, other is called a discriminator. The generator, what is it generate? Let's say I want to get an image. So what will, let's say in image restoration, I want to restore the image is corrupted. The generator will make some restoration, some expression it will do and it will generate it. Then it will give to the discriminator. What the discriminator will do? It will see from the data that is present in the ground truth. Will see whether how much matching it is, how much match data, how much match the generator has produced. It is how much, and based on that it will give a score, and that score will pass to the generator. Now the generator will know whether he has generated a good restoration or it is more to improve. If it says that the score is very low, that means need to more to improve. It will again regenerate that image. But given now this time it will regenerate from the earlier one he has generated, because now he said, okay, my score is improving, so that means I am actually moving toward the optimized state. So that means now the input will not be the fresh in initial data. No, now the earlier output will be the input now, and it will again regenerate it, and this will go on until the final restoration has been done. So in test time, obviously the output data, the ground truth data is not there, but since the model is trained, now he knows how much time he has to generate and finally get the restored data. Now, autoencoders are a type of neural network used to encode input data to compressed representation and then reconstruct it, typically used for tasks or like facial recognition and modification. So autoencoders, why I'm saying autoencoder? Because autoencoders basically come for unclassified data, okay, where we don't know, there is no labeling is there. See, when you're making a fake image or something, it obviously it will not be present, right? That means it should work the whole network should work both with supervised and unsupervised learning. It should be mixed up, right? So the GYAN model will work with supervised part and the autoencoders will work with the unsupervised part, because there we don't have the labels. We are faking something, so we don't know what actually it will actually create. We don't have label for this. We are creating new things. So deepfake can be used to alter facial expressions, replace voices, change backgrounds, or completely swap identities within the media. Now, why deepfake technology is important? Now, technological advancement. Deepfake technology is a result of advancement in AI and machine learning, especially in deep learning models. The emergence of GYAN and autoencoders has drastically improved the quality and accessibility of synthetic media production. Ease to use. With the growing availability of deepfake generation tools, even individuals without advanced technological expertise can create realistic looking deepfakes, which democratize content creation. Impact of media and entertainment. Deepfake technology is transforming industries by creating hyper-realistic effects in movies, TV shows, and video games. Celebrities and public figures can also be digitally rejuvenated or manipulated for roles, making deepfake technology both a creative tool and a potential source of concern. Now, what does all this thing I said is mean? So what it means? Means is, let's say there is a very popular celebrity and he take a lot of money to do a role. Okay. Now we have got someone like mimicking, like, so we say that they're duplicates. But even if the duplicates they're not exactly same, but now we have deepfake technology. So we can actually replace the duplicate with the original celebrity, and maybe that duplicate is working maybe 1/10 or maybe 1/20th amount, just taking the price of that celebrity. Obviously, that is a violation of rules. That is a violation of completely the rules and the ethics. But with the deepfake technology, once the movie is generated, and let's say he has generated, the duplicate has generated very good, and only thing is because of the face value, the movie is not getting popularity. So they have changed the face with some popular one, and maybe very good one, someone like that. So obviously there is a potential challenge. But let's see, there's another example I'll say. Let's say a movie has been dubbed, a movie is in some regional language. Okay, let's say in some regional language in India. But due to regional language, it is wide popularity is restricted. Now, if you just say translation, what will happen? Language to language translation, we can do the translation and we can add some subtitles. But how much popular a movie become with the subtitles? If it is actually the audio you cannot understand. But now, if you think that without what in earlier days the dubbing used to be done, someone is to sit and do it, mimic it, and do the dubbing, complete dubbing, right? But now with the deep fake, we can actually translate it as well as do the dubbing of them using just tools. So it will really popularize the movie and along with decreasing the human effort. So in that case, it is a positive case. The earlier one is a negative case. So again, it has both potentially threat as well as useful in the technology, in this technological background. So, but we have to see where we are going to use it and how we are going to use it. Now, application entertainment in film and TV, deepfakes can be used to resurrect, decrease actors, create more lifelike CGIs, characters, and even generate stunt doubles for dangerous sequences. Examples in film industry, digital recreations of late actors has been achieved using deepfake technology. So someone is not there, obviously, and with his permission, family permission, he has been recreated. Okay, it's like this saying in Star Wars, it wasn't used actually, and it is being very popular. So it is a positive sense. Personalized deepfake technology is being used for personalizing media experiences such as customized video greetings from celebrities or influencers. So, like the agency, every time you don't have to go for the celebrity itself to make a video and give it. The agency can make with the proper authenticated permission from the celebrity, from the deepfakes medias and videos for greeting videos and send it to the in the internet, in the social media. So personalized video ads where a celebrity face is swapped with the user face to create a personalized marketing experience. But obviously with proper permissions, legal permissions. The application of deepfake technology in education, training, social media. So education and training, deepfakes has potential educational applications such as creating realistic historical recreations for immersive learning experiences or simulating real-life scenarios for training in the field of medicine and law enforcement. So let's say we want to create a real court, law court, okay, and where people are present, and it's a game kind of thing where we are actually as if you are giving a trial and you are practicing it. So the people who are present are not a hypothetical people; they are really the people who are present in the courts, and they have some face. They have really, and with the proper permission, these videos have been made and using the deepfake technology. So it will be obviously very good experience. Every time you don't have to actually make the real courts there. Now, social media, like deepfake is being used on social media platform to create viral videos or memes. While this can lead to creative content, it also brings risk in spreading misinformation. When we come media, then on social media, obviously the risk is there. So face swapping is a viral meme or using deepfakes to create celebrities saying they never did it. Anyway. So like we nowadays we see, right, there are a lot of apps are there. We can use them, and there's these apps, though they are not very good, not very efficient, but we can swap the faces of this, that with them. These are there. So they in the background, they are working with these deepfake technologies. Misinformation and fake news. So why deepfake technology is controversial? So obviously misinformation and fake news, privacy violations. So deepfakes can be used to spread false narratives, manipulative public opinion, or even damage reputations by creating fake videos of public figures or politicians saying things they never said. For privacy violation, deepfakes can be used to create misleading or harmful videos that impersonate visuals, violating privacy or even causing personal harm. So obviously that you can create agitation using some fake political news, or you can make something which is actually actually has not been made, but made by the by deepfake, and actually you have publicized it. And this type of threats, if someone does, they are always will be attached with the legal issues. Why now, apart of that, there's security threats and legal and ethical issues. So security threats, a deepfake video of let's say of a CEO asking for a fund without potential trick with potentially to trick the employees or financial institutions into transferring large amount of money. Just we sometimes used to say that some I don't know, sometimes a lot of mail used to come that you will get a some lottery. If you spend this amount, then you will get a lottery. Earlier it was like this, just type of mails and or messages are there. Nowadays videos used to come. There's some popular person has said, if you spend on this amount, maybe only few in hundreds, and you will get this lakh or crores, okay, kind of thing. And the person who is saying is really a very authenticated person. So these type of things are there that are related to cyber securities, okay. And obviously, who are doing this thing, when they are catch on, they will be legal accountability will be done on them. Now, these are the legal issues we have said, but again, every coin has two faces. So good part and a bad part. So we as a researchers, we only focus on the good part. We are not going to use it in a bad way, right? We are going to use it in a useful way. So keeping that on mind, we are actually exploring the technologies that are used, because there are a lot of technology and a lot of people are working, and good groups like Google's and others, groups are working on it. So we are focusing on that, and since it's a new technology, so it have a lot of scope for do research. So we are focusing on that. Now, how deepfake technology works? So first is data collection, as usual. So deepfake models requires vast amount of data to function accurately, especially video footage or media or images of the target person whose face or voice to be manipulated. This data helps to train the model to replicate facial expressions, voice tones, and gesture. So we need a lot of data for what we want to make the deepfake for it. Now then training the model. So for training models, we need a neural network for feature extraction, and then we knew some GAN models to replicate it, and finally some autoencoders, so that the final unstructured data unseen data can be made actually can be generated. This process involves a massive amount of computational power and time. So for this measure, we need GAN. Obviously, we need GAN. So GAN are the backbone for the deepfake technologies. A GAN consists of two parts, as I said, generator and the discriminator, which attempts to create the fake result. Now, fine-tuning and post-processing. So once the model is trained, additional steps such as fine-tuning and post-processing are required to enhance the quality and realism of the generated media, ensuring facial movements, lightning, and shadow matches to the rest of the scene. All these things to create a proper good video or an image that we have to take care of, so that it look real. Because we said deep fake, right? So it should look real. It should not be look like this created. Now, where it is used, again, movie and television, social media, politics, video games. Video games is a very good place. Now, video games have become not just like a dummy video. The visuals are not very like artificial. Now, the visuals have become very more live. So it's a very good place where it is like in a positive sense. It has been used. Now, growing the threats of deepfakes. So we have already discussed on this, but we have keep some more slides, because in the researcher point of view. So while creating these things, you have to be careful that you have taken proper permissions, so that you should not be involved in any political or issues or legal issues. Okay, that should be very careful. And when you are creating the data, you have to be careful that time any agitations in the market is not going on, so that your data, your publication or your data can be misunderstood by the others. It should not be involved with the some identity theft or fraud. It should not be any spamming or scamming kind of things. So you have to be careful that your research should not be involved in that. If it is involved, you have to. If someone else want to use it, you have to be very carefully give declaration that you are doing this as a part of research, not for any other thing. If anyone is using it, that is not your responsibility. So this type of declaration you should give properly. So researchers are developing advanced technology to detect defects such as analyzing inconsistent facial movement, lighting, and now, as I said, there are two ways. One is creating, another is preventing. So many researchers are also working how to prevent. If this is there, then how to prevent. If this app is there, then how to prevent. Obviously there should be some fine details will be there, and what is that fine details. So they are trying to do that. So researchers are not just working on creating defects, they are also working how to prevent from the defects, how to understand this is a synthetically generated and it is a real data. So again, intellectual property and copyright. Of any time, if you are using really actually making defect of some person or some property or something, you take a proper permission. Otherwise, you will be legally in trouble. Defamation or reputation damage should not be done. So that you have to carefully understand then what you are doing. And reputation and regulations of defect. There are some standard regulations that like even few years back, even I now also like while if you are flying a UAV, okay, there you have to take legal permissions. Because that will actually do intrusion that can invade in your privacy, right? If there's a UAV in nearby in your home, where it can peep through the window. It may take the images that your personal images. They can peep through the windows, right? So that's why still now in India, I think, still now in India, we cannot openly fly in public areas, in all areas, we cannot actually publicly fly the UAVs. Only with permissions only we can fly. So similarly, deepfake is not illegal, but you have to take permissions if you're doing that thing. And if when you're publishing work also, let's say as a researcher, if you're publishing work, then you have to make proper declarations. Now, what are the technologies used is AI and deep learning. And apart of that, especially in AI and technology, we are using the GANs and autoencoders so that we can create the proper data for it. Synthetic data for the real life individuals we can create. Now, so basically, why this GAN model basically says the adversarial training. What does mean adversarial training? Adversarial training means here what we are mainly careful is like we are trying to see that if there is how much robust the model is. If I try to make a defect, okay, make a fake image. Now, when it will be recognized, what type of models can recognize it? Okay, it is a fake. It is not a fake. How much robust how much robust my developed data is. So that is called the adversarial training, where it actually improves to make the fake data as real. How much? See, if I make a fake data so real that even very good popular preventing technologies cannot understand the real or a fake, then obviously that means the fake data that I made is very good. So that type of things, that type of technologies will be popular in the market if you really make a real fake data. So for that reason, we do our adversarial training. With the adversarial training, basically help us to check how much robust my model is, how much robust it can create data. So for that, we used to try adversarial training. So when we do, so first is obviously data collection, then pre-processing, then we use the feature extraction, then we come for the GAN model for creation of the data, fake data, and then over the time we use adversarial training to check the robustness, how robust they are, and if they are robust, then finally we'll generate the final data in the as an output. Now, so how GAN works in the deepfake creation? Initially, the generator creates the rough images or videos that look nothing like the real images. The discriminator usually using the real data compares them and gives feedback. The generator then refines its output, learning from the discriminator's feedback to create more realistic feedback data. As I said, there are two CNN models or DNN models. One is for creating, that's the generator, another one is discriminating. Once the discriminating output will come, the score will come to the generator, he will again regenerate it from the last output data, and he will continue to do on till it will the score become very low, and that means the difference between the two generated and the original one become almost similar. Now let's say the role of GANs in face swapping and image generation. So GAN is widely used in face swapping defects. Like there is a face because this type of controversy we see many times in the news. Okay, so that's why I've taken this thing. So a target face, for example, the face of a person in an existing video is replaced by a source face, that is the face of the person intended to appear in the video. The generator, how it will work? The generator learns the unique features of the source face, like the skin tone, facial expressions, and the eye movement, and seamlessly integrate them into the target video. So over and over iterative method, the generator will generate, discriminator will discriminate will generate the discriminating score and pass it to the generator, and generator will again generate, and finally it will replace the original face by the given face. Now image generation, GANs are used to generate highly realistic images of people who do not exist. And these images are difficult to distinguish from real photos because the people do not exist, so you cannot actually say that whether they have done or not done. But they are widely used now. Applications include generating faces for social media accounts or creating realistic avatars for virtual reality. So this avatar movies, so that type of faces are nowhere, and they are created by AIs. So something mixing four or five faces and a new face has become, and that type of face no one exists. But they have mixed up 4 or 5 face and make a new face out of that. Now only GAN is used. I will not, because GAN is again a very old technology. When deep learning come after a few years, only GAN has come. So now there are a lot of advancement has been done in GAN. So, and as the GAN has been advanced, that has been used in deepfake also. So conditional GAN is widely used actually. So what is conditional GAN? A conditional GAN is an extension of GAN where both generator and discriminator receive additional information. For example, labels, attributes, or class data to guide the generation process. So it's conditional, that means some conditions has been given. That means some additional information can be get so that the generation of the fake data should be done in a less time and more accurately. The additional input allows CGAN to generate images or videos based on certain conditions. For example, specific facial expression or actions. So given the special certain condition, it will generate. The role in deepfake creation, the CGANs can help to generate specific context-aware deepfake media by conditioning the generator with labels. For example, generating a smiling version of a person's face. The smiling version was not there, but the context was smiling. So he changed this to smiling face. There are a lot of apps nowadays. I hope you people have already used them. Eye opening. You upload an image, it will say eye opening. So you can, they open your eyes, and if it's a smiling face, they'll make your face smiling. Though I have tried some of them, but though they make very weird, even they are very unrealistic. But you never know. Maybe in another 10 years, this type of apps, the technology there, this Google and all this thing, OpenAI, they are generating. After 10 years, they will come in the form of app where normal people will also use them, and it will actually create a real-time data. So CGANs can also generate fake voices or simulate specific emotions or accents in audio deepfakes. Autoencoders in deepfake technology. What are autoencoders? So autoencoders are neural networks that learn to encode input data into a compact, low-dimensional representation and decode it back to original data. The encoding part allows the model to extract the most important features from the input, while decoding part reconstruct the data based on those features. So basically, autoencoders has they encode the input data in a compact format and give importance to the most important features, while decoder in the encoder part, while in the decoder part they will reconstruct the entire data. The application of autoencoders in defect creation is autoencoders are used for face swapping and identity transfer, where they help to extract features of one face and apply those features in the other face. Let's say how we human understand this is the person A and this is the person B who have almost similar face. Still we understand. We understand from the way they smile, the way they look, the way they change their eyes. Though they are very similar, still there are fine differences are there. That fine differences are actually captured by autoencoders. That fine differences, and they actually transfer the identity. This identity to the other one when they are actually doing the face swapping. The encoder learns the features of a person face, and the decoder reapplies these features into the onto another person face to create the seamless defect. That's all. Now defect creation using variational autoencoders. Now I say autoencoders. Now I come to variational autoencoders. GAN, conditional GAN. Autoencoders, variational autoencoders. So that's the advanced version. So what are variational autoencoders? Variational autoencoders are extension of autoencoders that introduce a probabilistic element, enabling the generation of new data points by sampling from the learned distribution. So unlike standard autoencoders, variational autoencoders are particularly good at creating diverse output. For example, generating multiple variations of a face. Let's say we have different expressions in a face, and they are very different, like stunned, not just smiling and crying. We have smiling, crying, and neutral are very common, right? You have to a scared face, a stunned face, or a let's say face like which is very uncommon. The expression is very uncommon. So that type of things if you have to create, then it's always good go for variational autoencoders rather than just autoencoders. The role of variational autoencoders in defect creation. So variational autoencoders can be used for generating diverse facial expression or even creating entirely new version of a person face, which is usually application is face swapping or body manipulation. So obviously the work that autoencoders do, that they will obviously do. Rather, it will do in a more better way, more finer way. They also help in data augmentation, improving the model's ability to generate high quality defects by providing multiple variations of a target person. So they also help in using data augmentation. So that means if you're augmenting data, that means it will make the high dimensional data. If the high dimensional data is there, features are more there. With more features, more better ability is there. Now RNN for defect creation. So are RNNs used? Yes, they are used. Where they are used? So we'll discuss on that. So recurrent neural networks are type of neural network designed for sequential prediction, such as speech recognition, time series forecasting, and video generation. So RNN use feedback loops, allowing the models to retain information about the previous input in the sequence. So this is the base of RNNs. Now how the RNNs can be used in defect, that we'll see. Now video generation. RNNs are critical in video defect creation because they capture temporal relationship between the frames, enabling the generation of realistic facial movement or even actions across multiple frames. Let's say till now we are talking about facial thing, right? How the facial will be. Now the event has been occurred. Event is occurred in a video. So there is an activity has been occurred. Now this activity has to be every time the face and the movement of the face, not only the facial expression, the body posture, the movement of the face has been changed. They have maybe it was not first time it is a complete face to face. After few frames it has in some angle. So that means we have to also capture the temporal relation. So there comes the role of RNN. So temporal relation should be maintained. Otherwise, if I take the first frame and then after and change the expressions, obviously in after few frames the angle of the face has been changed. That you have to keep in track. So here it comes the role of RNN along with the GAN and the autoencoders. This helps to ensure continuity and coherence in the video sequence, preventing jerk or unnatural transition. That is called unnatural transition, okay, between the frames and in defect videos. So obviously, if there is unnatural transitions, then anyone can understand this video is created. This is a fake video. This is not an original video. So that's why the RNN will come for that. Now transformer network. Now if RNN is there, can transformer can come up, because transformer is a better version of RNNs. Yes, because it is also along with the sequential. It does always have self attention. So it is a better technology. So can it have a role on it? Yes, it has a role. So transformer are advanced neural network that use self attention mechanism to process sequence of data in parallel, significantly improving efficiency in tasks such as language translation, image caption, and video understanding. Now, how it is used? The transformer can be applied in audio defects, because audio defects is again sequential data. So it can be used where they capture dependencies between different segments of speeches. This allows for generating more coherent and contextually correct synthetic voices. So, because in voices we don't have any spatial data, where mainly the sequential data is there. So in sequential, the coherency and the context contextually should be correct. There, the addition of transformer network is always a good thing. For video generation, transformers can be used to process sequence of frames, ensuring high quality facial animations and even slicing lip movements with generated speech. So lip movements. So once you change, let's say you are doing a dubbing. So once you change, not dubbing, if you are changing the, let's say language dubbed. So once you change the language from, let's say from English to some Hindi. So obviously the lip movement will also be changed for the same sentence, because the way the English language line has been said, the same way the Hindi line will not be said. So the lip syncing should be done. So that can also be done using the transformer network in the defect generation. Now training defect models. We'll start with data collection and preprocessing. So importance of data. Obviously, it requires huge amount of data. So large data sets for real images and videos for training. And the quality of data significantly impact the performance. So what type of quality of data? Is it noisy data? If it is there are a lot of outliers, what type of data? What type of lighting conditions in the data? What type of expressions are there? All these things matters a lot while training the things. Preprocessing, face alignment and normalization. The target face is aligned to ensure consistent orientation and size, making it easier for model to learn the key features. So initially when you are learning, you should have some very high quality, high resolution, good facial expression and resolutions, so that it should learn the model properly. To make the model learn properly. Then data augmentation, like different rotating, flipping, changing the lighting conditions. There are different data augmentation models are present. We use them for normalizing the data. So that should be properly used, so that all angles, all lighting conditions, all facial expression should be covered in one go. Now optimizing defect model for realism. Now what is the optimization techniques we use? So loss functions, key to modeling training. Loss functions guide the network in reducing the difference between real and generated data. In defect models, common loss functions are pixel-wise loss, adversarial loss, and perceptual loss. So these are the three loss functions which are commonly used in the defects to measure how close the generated image or video is to the real content. Fine-tuning. For fine-tuning, you can use pre-trained model like style GAN or cycle GAN on domain-specific data that can enhance the realism of defects. More models is exposed to a person's unique characteristics, the more convincing defects will be. So as much as it is more real to the real data, real images or videos or audios, it will be more convincing. The use of perceptual losses, the traditional loss function like pixel-wise loss are often insufficient for ensuring visual quality, leading to an introduction to perceptual quality loss. So pixel-wise is pixel by pixel loss, but perceptual quality, overall context and the perceptual perception about that scene, about that video, about that audio will come up. This function helps to maintain high-level features like facial structure, expressions, and identity by comparing high-level features of both real and fake images instead of pixel by pixel comparison. Now, real-time deepfake generation, for some application, the deepfake generation needs to be done in real time. So optimizing the models for speed without sacrificing the quality is a critical. So it is really a challenge. Model compression techniques like knowledge distillation and quantization help to reduce the model size. Or teachers training models are there, which are also part of knowledge distillation. They can be used to reduce the size of the model in the testing time and increase the processing speed. These techniques maintains a balance between the accuracy of deepfake generation and the computational efficiency necessary for the real-time application. So hardware equivalent, again, GLU accelerations, GPU accelerations, deepfake models, essentially, and especially those who use GANs. This GAN is use two networks at a time, not a one network, two neural networks at a time. GAN and DNN models require high computational resources. GPU with large amount of memory are crucial to speed up the training and generation process. TPUs are obviously better because tensor processing unit, specialized hardware designed for DNN models, and is becoming increasingly important for deepfake model development, reducing the training time and making the models more scalable. But obviously TPU is lesser available, GPUs are much more available. Now, challenges: deep learning models for detection. To combat the speed of the defects, researchers have developed deep learning based detection model, including CNN and RNN, for inconsistencies in facial movement, lightning, and subtle artifacts that defect model may introduce. Visual and audio discrepancies. Model methods focus on identifying mismatches in the eye blinking rate, lip syncing, and audio-visual mismatches that occur in the defect content, which might not detectable in human eye or errors. So these are the way by which we can actually researchers use this type of models so that they can know that whether it's a fake or it's a real one. AI created fake media or it's a real media. Now challenges will come as defect technologies, so that method used to make them are more convincing. As the solution are being better, the manipulating methods are also being better. So they are making more and more convincing fake data. Detection tools need constantly update to keep up the rapidly evolving technologies used to create fakes. So as we say, this virus and antivirus in computers we use. In our OS we use antivirus, right, to protect from the virus. But again, some new virus will come. So again, we have to add some packages for the antivirus. So the same thing is here. Once you have make the fakes, if the fake can be catched by the experts, then they will again the creator will make the more real like fakes, and the researchers have to, for preventing it, again they have to create a better solution for it. So obviously, the solution is make a better realistic movement and facial expressions in the AI based method. In the AI based detection method, if they can actually distinguish between the movements of the facial movements or hand movements or the postures of the real videos and the fake videos, they can differentiate it. Then obviously they can do it. But again, if the solutions can do it, then the creators will also while making the defect, they will try to mimic the movements, the eye movements, facial movements, gestures, which is almost similar to the real video or real data. So researchers are developing AI-powered systems that aim to detect defects by identifying the inconsistency and anomalies that the human eye cannot easily perceive. So facial analysis, body movement analysis, audio analysis, and finally, we can say there are solutions like blockchaining solutions which explore the way to track the authenticity of the media content, ensuring the videos and images are tagged with verified timestamp. So one is you go for watermarking, invisible watermarking. Another is blockchaining methods. So where there will be timestamp that this timestamp with this authenticity, that this is made by this particular popular person. So that, or digital signatures like watermarking or digital signatures, they can help to prevent from the what is legal, what is illegal. Apart of that, otherwise we have to use tools again, or researchers have to use tools to differentiate between the two medias, which is fake and which is not fake, and have to see based on their features present there. So data scarcity, as you said, it needs a large data. So if there data scarcity is there, training will not be proper. Synthetic data generation, how much synthetic data the data is the synthetic data that is generated is how much synthetic it is. Is it look like real? Is it can supplement as a real? How much bias it is? How much consistency it has? So that you have to take care of. Legal issues are there. If you're doing a research on it, you have to take legal permissions. Ethical permissions always is required so that you should not be in trouble. Now, till now, we have done an overview of the deepfake. Now, we'll come for few models. So, that are popular models that are already existing. Till now, is there any questions? I know today's lectures are a bit technical, but because in earlier lectures, I have already said the basics of the AI and ML. Now, I'm going more details in the technology. So, okay, now we'll discuss 4 or 5 models which are in deepfake, which are now popular. So, Deep Face Lab. So, Deep Face Lab is a face swapping model, which is a leading software. It has come as a software also, leading software for creating deepfakes. So, it has been published in 2023. So, the concept is, the first is design concept. The purpose is deepfake is a popular deepfake model used for face swapping for images and videos that work for a face of a person of a video, preserving the original face with expression, lighting, and movements. Key components are used autoencoders and GANs to create realistic face swaps. The system first learned the facial features of both the source and the target. Source is what is present, and targeted where it should be mimicked. Then generate the new content. The data collection and pre-processing. So collect the high quality images and videos for both the image and source faces. The data set should contain a variety of expressions, lighting condition, and head pose. Now pre-processing to detect the faces using face detector models like OpenCV or DBLab, crop, align, use different of normalization techniques to make to get a different variations. Finally, model in the implementation, we use autoencoder architectures, so encoder and decoder. So autoencoder architecture, and the encoder extract the features of the input image and video, and decoder reconstruct the image after encoding, but with the target face feature. So earlier we always say encode and decode, but here always we mention extra is initially it's encode, but when we decode with the target face. GAN integration, adversarial loss in GAN ensures the generated face is realistic by pitting the generator and a discriminator against each other. The generator creates a fake face while the discriminator distinguishes between the real and the fake. That's the usual activity work of the generator. Finally, the model training. So while we'll do the training and autoencoders, train the autoencoders and the GAN simultaneously to generate realistic face swaps, and it will have some with some proper batch size, learning rates, and epochs. That are the training details. I'm not going in detail because these are again paper specific. This model specific. So they have used this type of batch size, this type of learning rate, and this type of epochs. Finally, they use evaluation. So what are the evaluation metrics they have used? They have used PSNR and SSIM. These are basically used for structural similarity as well as the to check how much similar the two images are. To measure the image quality, subjective evaluation via human inspection is also common. So testing is they use a variety of real world videos to test how real the model generalize across different lighting, angle, and expressions. So this was the first model, that is a deep face model. So they have basically used here simple GAN and autoencoders, apart of feature extraction using the CNN models. Now next is another face swap model. So it was deep face lab. Next is face swap. So FaceSwap is originated as an open source deep learning based project using tools like TensorFlow or PyTorch. So it has been developed by some open source community, and it is available in the internet also. So you can try this FaceSwap. I think in GitHub or somewhere you will get the code directly. So it is again a model which from where you can actually start doing your work if you want to do some research in this direction. So it is because it is open source. It is written here. It is an open source. So it is available. These codes are available. Open source tool. The tool is available and the codes are available also. So key components are CNNs for feature extraction and auto encoder for face generation. So for data collection and preprocessing, so obviously we have to, they have done data collection over the images and videos, and to ensure high resolution and diversity of data present, then they have done processing using OpenCV or DBLab for feature extraction and align the faces by cropping them into fixed size and resolution. Then model implementation, they use autoencoders. So where encoder and decoder encode the facial features, shape and eyes and mouth and nose. Decoder reconstruct the face, but with the target face. Now training the model. So loss function here they have used L2 loss, that is pixel wise loss and perceptual loss. These two losses they have used. So for their model, and for training they have used the, GPUs. For testing they have used the PSNR and SSIM as the evaluation metrics, and to create the final defect images and videos. I think you can, since it's open source, it's a very good place where you can start your work if you really want to start some research work or development work with the defects. Next is cycle GAN. So cycle GAN is again a very good work. It was published in ICCB 2017. So ICCB is one of the very good conference actually. So they have first says about the cycle. They use the cycle GAN. And that cycle GAN actually has been used widely for image to image translation from one image to another image, and you completely make a different, not completely means keeping some coherency, you are actually changing it. So there they have used it. So it is widely used and very good paper actually, good work. So purpose of cycle GAN is basically to image translation, turning images from one domain to another without paired training data. So there is no paired training data, but still can do it. It is often used in defects for tasks like age progression, style transfer, or face swapping. So age transfer, like you have seen, there are a lot of software. Like say when you are in 20s, how will look? When you are in 30s, how will look? When you are 40s, when you look? When you are 50s, how will look? So that type of things which actually does not exist, but you are making the translation of the images based on some conditions. Key component is generator and discriminator because there is a GAN model is there. Trained with adversarial loss and cycle consistency loss. So there's the extra thing they have added is cycle consistency loss to maintain the integrity of the generated image. Next is again data collection. So they have done a huge amount of data collection. They have pre-processed it, resized it, and normalized it for the training. Then for model, for generator, they have used that they have mapped the images from source domain to target domain. In the discriminator, they have generated the images that are more realistic, and to determine that the score should be very low so that it should look more like real like. Now what is the role of the cycle consistency here? A key feature of cycle GAN is the cycle consistency. The model enforces that translating an image to a target domain and back should yield the original image. So here they are actually, while from normally GAN will do from same source to the same source they will recreate, but here they are taking from the source and actually generating the target. So that's why they have introduced this new feature which actually enforces a proper translation from the source to the target, and for that they have used some scores, and the scores will say about how much good the translation is. Now for loss functions, they have used standard loss function, adversarial loss, and cycle consistency loss. And for training, they have used GAN training with unpaired images of both domain, source and target. And and based on the typical, they have, since it's a very big model, so as I said, this take typically several days depending on the data size and the model complexity. So evaluation, for the evaluation of models, the ability, they have taken style transfers. This is used in this style transfer, face swapping, this type of thing. This is been widely used. And again, the metrics are PSNR and SSIM, and visual perception inceptions can also be used. The fourth one is style GAN. So it is again another very good paper which is come in 2020, and it is in CBPR. It is one of the best conference in computer vision and ML machine learning deep learning domain. So style GAN. So the concept of style GAN is basically again the same. The idea is same. The motivation is same. That to generate high quality fake data, fake images, which look like real faces. And key components are using our progressive growing techniques for stable and high quality faces generation. The network learns to map latent vectors to different levels of resolution, starting with a low resolution and progressively increasing it. So that was the main concept. So I will come how it is happening. Now, first is data collection. So basically they have taken the dataset Celeb A and FFHQ dataset. The Celeb A and FFHQ datasets are available as open source, and they are very good dataset for face. And they have diverse type of race, age, gender, and expressions faces. Pre-processing, align the faces, crop them to a uniform size, use different normalization techniques so that it can be adjusted to the lighting and color conditions. Then in architecture, first is mapping network. So converts random latent vectors into a style code that controls the generator's output of each layer. Now, since it is more robust, what they're doing, each type of expression, each type of changes, they have used the latent vectors, and the latent vectors are feature vectors, and these feature vectors are basically help to, and what they do is and then they said that these vectors are for each style code. If there is a variation, then different vectors have been generated, and these variations they have used for mapping in each of the layers, in each of the generator layers. Now, generator generates high quality faces by progressively adding details starting from a low resolution to high resolution. Discriminator evaluates whether the generator face is fake or real. The role of the discriminator has not changed. The role of generator is not changed, given that we have extra added the mapping network, which actually convert each style code, each latent vectors, that are each features of each of expression or lighting condition, whatever it is, whatever the changes are there, for each as a style code, and controls the generator output at each layer. So that is the extra part that has been added in the GAN model. Now, for training, they have used a large-scale data FFHQ dataset. And so, obviously, again, if it is this is a very, very large-size dataset, okay, and this extensive dataset use extensive computational resources, so which take over the days, not hours, to compute it. So, and maybe using multiple GPUs also. So, progressive growth strategy enables the model to learn from lower to higher resolution and reducing the risk of the model. Okay, the evaluation is they have used a human subjective metric, which is called FID. So that type of metrics they have used, and for testing ability to test the model ability to generate realistic faces from random latent vectors. So they have, apart of the normal matrices, they have used an extra matrix that is called FID. So the last one, till now we are mainly last four we are discussing mainly on the images. Now we want to just quickly see one model on the videos. So RNN for video deepfakes. So there is a few short video to video synthesis. So it has also been published in 2021 in a very good conference, NeurIPS. So it is also a very good A-star conference in our domain. So what does it say is, so purpose is basically it is using RNN for frame generation, for video for frame generation and temporal consistency, and it learns to generate each frame of the video while maintaining consistency in facial movements and expression over the time. Key components is RNN to capture temporal dependency between the video frames, ensuring that the generated faces are realistic and aligned with the movement patterns at the source individuals. First is data collection, obviously. So huge amount of data should be collected, they should be pre-processed, they should be normalized. Then model, so RNN architecture, either you can, so they have used the LSTM because LSTM is one of the good RNN models. So they have used LSTM to capturing the movement and dynamics of facial expression across the frames. Then they use GYAN, obviously they have to create it. So LSTM cannot create it. So something should create it. So for creation, they have used GYAN for face generation. So after RNN learned the temporal dynamics, GYAN is used to generate high quality frames. Now training, so they have trained their RNN to learn the temporal sequence of facial expressions, and they combine this with the GYAN-based face generator to produce the frames that look like target face while retaining the temporal consistency of the video. Evaluation matrix, they have used temporal consistency matrix, PSN and SSIM, they have used for the evaluation. Now we'll conclude quickly. So the things that we have already discussed, but I'm just concluding it because these are the important part. When we are discussed about defects, these things we should keep on reminding multiple times. So I'm just quickly again saying that the impact of defect on society and trust. So obviously it has a good side and bad side. So we have to keep on that it should not be used in erosion of the trust or manipulation of public opinion. That should not be done. Or it should not be done in such a way that it will affect the psychology of a person. It should not be fabricated. The videos and images are fabricated in such a way that it really create a personal psychological imbalance. This type of things should not be done. So we have to be careful that the privacy should be maintained. Challenge in social media platform like in Facebook and Twitter, where they're still in struggling to prevent defects so that the videos cannot be downloaded from there. If they're downloaded, they cannot be manipulated, and if they are manipulated, they can understand that which one is real video and which non-real video, because this type of platform immediately actually spread the news very fast. So if illegal news is spread, these companies are being sued. So that's why they're really struggling a lot to understand the fakes. For legal framework is still they're making. We have not come. Still, every country have now globalized framework has not come up. Legal framework has not come up. Every country are making their own legal framework so that the malicious defect provision acts type of things should come up, and it should not be misused. So defamation, privacy laws, ethical dilemmas, these should be there. Otherwise, this should be keep in mind when you are working with the defects. Now, future of defect technology. So as the technology advanced, defects were becoming more sophisticated with better integration of facial expression, voice tones, and environmental factors. This makes increasingly difficult to detect the manipulated media. AI-driven system, the future may seem AI-driven systems that can accurately detect defects in real time across large volumes of data. So the way I said that creation is becoming easier with the technology, again, the detection system are also will be better with the advance of technology. The system could be implemented across social media platforms, news organizations, and enforcing laws also for the fake images and fraudulent activities. Ethical standards should be made. Government will come up with proper rules and regulations that what type of legal action should be taken against this type of actions if they are using illegally. So new applications, we should have some new applications will come up. Now we know that it is in healthcare, in entertainment, in virtual AR, VR, in education. But as it will be more popular, new applications will come. Okay. And as the applications will come, the rules and regulations will increase. So stricter rules will also come. So both will evolve together. There may be cross-domain applications like media and entertainment. So defect can be used like in gaming and the entertainment. There can be used whether for different type of cross-domain applications can be found in this type of places. Even in music industry also, we can get a lot of places where cross-domain applications of defects can be found. As you said earlier, also AR/VR is a wide places, especially these avatars. That all these avatars has not been created by anyone. They are mainly created by AI. Obviously, some human inputs are there because the movies have been long back. But now maybe after 10 years, all these things will be created completely by AI. Okay. So now interactive learning, all these things are widely used. And will be much better and interactive when this defect will play a good role in a good sense in AR/VR. So in surveillance system, so we see in the surveillance system or voice or facial impersonate, again it is using in a bad way. Again, because it is impersonating person, it is impersonating someone's voice, someone's face. So that is a threat. So security system, it is a very big threat. So in that case, we have to protect it using some biometric systems, that like fingerprints or something, that we have to go for that. Economic effect, there's a lot of, if there is a really impersonation, some celebrity, some popular person, some politicians, it can really create a huge chaos in the market, or maybe there may be huge financial loss. So that kind of thing can happen. So we have to be careful of that. So where are the open challenges we have? Still, we have improved detection algorithms. Detection algorithms can be still improved. Human perception studies can be properly done. There are still space. AI safety and bias. So there we can work how we can fair, safe, and unbiased things can be done. Content provenance. The research in digital watermarking and content traceability. There is still, earlier they have get stagnant, but with the rise of the deepfake, now again new doors have been open for this digital watermarking and content traceability. So there are a lot of scope for working over there nowadays. So next generation, we have transformer models, attention model, we can work on that. We can work on the voice synthesis, we can work on AR/VR, we can work on individual customizations. There are challenges like in the how the feature extraction can be made better by CNN, how the forensics can be made better for CNN. Apart of that, apart of normal biometric, can we use blockchains, and how good that blockchains will be if we use them for the authenticity. So in entertainment, normally this defects continue to devilize in industry by enabling actor impersonating, de-aging, and special effects. So that are in good way. Then advertising is also used. There is also in good way. There are a lot of brands they are using tagging, and they are also taking proper permission. Education also we can use. So they are also good places. And AR/VR also there you can use. If you use, it can be really give a good effect. So healthcare already we are using AI generated media, already using IoT based model we are using, but there are still a lot of places where we can use and where we can use them actually. So developing anti-defect tools. So anti-defect tools are tools that can actually help to understand is it fake or not fake. So encouraging the creation of sophisticated AI-based detection system to identify and flag defect content. Policy framework, government must create laws and regulation to mitigate the misuse of the defects in the areas of politics, journalism, and entertainment. Public awareness, educating the public with defect technology and their potential misuse, ensuring individuals can spot defects and report them. So what are that? Who are the popular brands who are actually making them, or both detection as well as the creator? So DeepMind by Google, Facebook Meta, then Adobe. So these are the big companies. Nvidia, they are all working on this defects. So now small groups, small groups have started to work, but who have started working widely and from a long time are these big companies. Research labs, MIT Media Lab, Stanford University AI Lab, then University of Washington, University of California Berkeley, all they are working in defects, and from there only the defects, the initial papers all are from there only. Initial research has come from them only. So, okay, finally, we are focused. Defect technology is being used in the DH factors. As I said, the studios seek to enhance production capability by reducing the need to expensive reshoots and recreating realistic CGI characters. So obviously this is the why the film production needed defects, because so the reshoots should be less. They can use some AI and defects to make the sequels or make the with the less number of reshoots, less number of changing in the attires or the expressions of the actor. Gaming, as I said, gaming real avatars and will give a real better experience. Immersive experiences can have. In music industries, we can have a lot, because we can, especially the translations, we can have lot. Then virtual performances, synthesizing new tracks, all these things. It can really, if it is used in a good way, it can help the musicians in a better way. It helps in marketing. It helps in virtual influencing. It can virtual anchoring, investigating journalisms. All this where in these places, the defects can be used. If they are used legally, they can help a lot way. So finally, conclusion. So despite the risk, defect technology holds immersive promises in the field of entertainment, digital media and education, where it can be used for innovation and enhancing experiences. The key lies in developing ethical guidelines, advanced detection technology and accountability measures. That is the key thing. So perillful misuse of the technology may lead to malicious content and may produce challenges in security, privacy and public trust. Future defect technology require collaboration between government and technology developers and regulatory bodies. So again, summary. So defect technology has immense potential to positive use in the field of entertainment, education and digitals. So we have to be careful about the legal issues, and looking forward, defect will, because it just come only few years back. So we are looking forward so that it will really grow and give a good impact and will ensure trust and provide benefit to the people rather than the risk. So these are the publications related to this, my publication. So recently we have published two papers in III on this defect, on related to defect, and one paper in CVPR. So these are very good conferences actually. And okay, that's all. So now questions, please. Any questions from anyone? No questions? So I want to thank you everyone for patiently listening to my lecture. And if you have any doubts, any questions later on, if you read it, so you may contact me via email from here. And you can also check my homepage. If you are interested to work in future, you can also work it. Yes?
Thank you, ma'am.
Yeah, thank you all. So I'm closing the session then. From IIT BHU, okay, is there anyone? Please, can you close the session? Okay, I'm closing here. Okay, thank you. Bye. Okay.